That. Could I have a sound check, please?
Sound checking.
Very good. Thank you, John. Turn that down a little bit. Came through loud and clear. Okay, let's get the live stream picture set up here. Okay, it looks like we're ready to go, as far as I can tell. Okay, welcome everyone to the Keshe Plasma Reactor group for Tuesday, August 23rd, 2016, or Wednesday, August 24th, 2016. Take your choice, depending where you are in the world, and if you are in the world. Okay, speaking about otherworldly things, I think we should move right into Lee Coates here. Let me see if I can get, I hope he's ready. Let me see here. I have to get this. Oops.
Sure, why not?
I think I just muted your video accidentally, Ashley. Can you restart it maybe, and I'll stop mine? Maybe I have to ask you to start, or is that the way it works?
I got an error note that says you can't start your video because the host has stopped it.
Oh, jeez. What an idiot.
Oh, wait a minute. There's
There.
start my video. Okay, I'm back.
Okay, there we go. I don't know who this host guy is, but boy, we're gonna have to give him a talking to. Okay, let me see here. I just have to make sure it stays on my second channel by pinning it. And back to Spotlight. There we go. Okay. So, what do we have here today? It's something new every week. Boy, you're busy bee with your constructions, I must admit. So we see. Go ahead. Sorry.
These are my two new MagGrav units that are going to go with the latest creation that I was showing you last week.
Okay, and refresh us how that fits into your grand plan.
Well, last week I just showed you with an old MagGrav unit I made back in November, which had some defects and whatnot, but I just threw it together quick last week to see what would happen with those two fridge compressors, and didn't get any results. So I've been working on these two new MagGrav units, and with whatever improvements that I have gleaned over the past few months, I guess. So I think I've ganced my coils better. The ping pong balls in the middle, I noticed when I made the starship formation with the spinning ping pong balls there a year ago, all the moisture drained. Well, not all of it. Maybe 80% of the liquid drained out of the inside or evaporated out of it. So these ping pong balls aren't waterproof. The moisture can come out over time. Sort of like the water bottles you buy at the store. You buy the water, and after 2 years they shrivel up like a prune. You know.
Is that right? I haven't noticed that, but that's an interesting observation. Well, it's true that plastic is not completely sealed. It is somewhat porous, but I didn't know that the moisture would go through. That's interesting.
Yeah, so that's what I discovered. I was taking apart that old unit, and all the four ping pong balls were almost empty.
Huh.
So Mr. Keshe was talking about a product for holding helium.
Yes, right.
In or gas. So I ordered this stuff called High Float from our company on Amazon, and that's for sealing up helium balloons inside. So the only thing is it's water soluble. So since I'm going to put liquid plasma in these ping pong balls, what I did, I coated the outside of the ball with it, and maybe that'll hold it in, because I don't want to be taking this thing apart every year to refill the balls or whatever every 6 months.
Yeah.
It's either that or got to come up with a better ball that's actually waterproof.
Right. Yeah, that might not be a bad idea.
It may not be that the water's leaking out of the balls. I've got three containers of GAN, CO2, CH3, and copper oxide, and my CO2, which is in the middle of the stack, is rapidly depleting itself of water while the other two are staying fine.
Hmm.
So it may not be coming out of the ball. It may just be turning into plasma and leaking out into the ethers.
Uh,
Water is your food or fuel for the reactor. I wonder. It turns it into the plasma vapor, and that's what causes everything to work, perhaps.
Yeah.
Interesting.
Anyway, last couple days I've been making capacitors. I got a bank of capacitors on the bottom there, the new variety from the new blueprint. Yeah, but I was thinking after I put them in there, I'm thinking, how is that going to affect the plasma flow in this maggrav? If you put something on the bottom, it was a convenient space, not doing anything. Uh, so it's straight in here, right at the bottom. I was just wondering if that's a bad place to put it.
Well, the commercial unit, the capacitors are on the bottom.
Are they? Because
Yeah.
the other option, like on this one, I put them around the outside here and on the tray. I thought maybe that's another option. So I just thought I'd ask you guys if you had any opinions on that, as to should we be keeping the area around the coils free to get a better plasma flow, or does it matter, or whatever?
I don't think it's going to do any make a whole lot of difference. We've got all kinds of iterations, top, sides, bottom. They all seem to work.
Yeah, well, I'm just trying to get the maximum efficiency here.
Yeah, like what if, for example, we put the whole works inside of a vacuum chamber and vacuumed it down and then introduced only the gases that we wish to into the chamber? And would it have some kind of special effect, perhaps, in that situation? It might super activate the plasma, for example.
You might have some issue with your GANS balls in the middle.
They would likely explode, yes. So that could be an issue. Exploding balls. No, they might take it actually. Ping pong ball can take a full vacuum, so it could probably take the vacuum pulling on it from the outside as well. In
Okay.
theory.
Another thing on this design, they were made to fit inside a 5-gallon bucket. So
Wow.
just for carrying them around, or taking them. I want to go around to construction sites and demo this system once I get it working. So that's it was sort of, that would be a convenient way to house it, I thought, in the 5-gallon bucket.
Yeah, it's kind of neat.
And the other and Mr. Keshe was always talking about putting these things into liquid plasma or something. I'm not sure whether he meant these units themselves or he was talking about some other units, but I was just thinking, what happens
Yep.
if I put it in the 5-gallon bucket and fill the bucket partially full with liquid plasma, whether that would do anything for the, the
Well,
maggrav, make
that's
it better,
a
or
very
cool it better.
very interesting concept. Yeah, I mean, when we think about it, it's kind of a plasmatic capacitor sort of setup with the coils and so on. It's a a giant sort of capacitor in a way, and we have the plasma capacitor as well. Like Nikola Tesla and other early experimenters, but especially him, used these huge tubs for capacitors, filled with like salt water and topped with oil. Put oil on top for to prevent the oxidation taking place and so on. And I'm thinking, well, what if we put, distilled water on top, which is a non-conductor, for example? Would you be able to put the whole works inside of a 5-gallon bucket and put in 3 gallons of distilled water? That would be an insulator, and theoretically, it the system should operate still, but it would be under essentially a vacuum condition as far as the coils and so on go. They're no longer exposed to oxygen and the air and atmosphere and all the fluctuations of atmospheric pressure. They're under a more or less constant pressure of the water, but it acts as more or less a vacuum inside as far as the plasma goes. So it's interesting. Or what if we use salt water? I mean, it would seem like it would be a disaster. Plug it in and it should start smoking and steaming, but I don't know. Maybe it would work. Who knows?
Anyway, that's a thought. Might experiment with that one, but
fill her up, Lee. See what happens.
If anyone else is going to make one of these, I put the filler for this is the filler to fill the tubes here with
nice. Okay.
with plasma. It would probably be better to turn this filler on its side, because then you can always turn the unit on its side to fill it. It's sort of in the way, sticking up top. That's just
oh yeah, I see.
A flaw of my design right now that I think, because if I'm going to put some water in the bucket, I'm going to probably have to move the capacitors up on top. I don't think they would be suited to sit in the water, but anyway, so, and then I got to get this thing on top if I ever figure out how to wire it up.
Oh man, that looks deadly. I don't know if that would pass security. It's just my water bottle, officer.
So anyway, when Bernie was showing us that blueprint there last Thursday, he never showed us where to connect the other wires to.
Okay.
I think he didn't show us page 7 and 8 on the blueprint, so I didn't know where they were supposed to connect to.
Yeah, it's worse than the old Batman series, which you have what they call a cliffhanger at the end, and Batman's in a serious situation. But stay tuned to next week. We'll find out what happened to Batman and so on, and it makes you keep coming back.
So maybe we'll learn some more this Thursday. I don't know, but and the other thing is, where do you connect the wires to this to actually connect it to the maggrav? I'm not quite sure, but
that device is a field generator. Once it's wired up, it just creates a massive field. And there is an unofficial wiring diagram out. I'm not sure where this comes from. It was publicly placed on Facebook, so I'm pretty sure it's. Oh, actually, it's Miriam Quaranta drew it up. I can share it if you want.
Yes, please.
Sure, why not?
And we'll see if maybe we can discuss it and see if it makes sense. But that's essentially it. It's a little confusing when you first look at it, but once you look at Vernie's top-down view, it does tend to make sense after that. The double coils here are your coils. These are the bottles, and you basically mount them so that you're driving this thing in a spiral. Now, whether this is correct, I can't say, but it makes sense to me.
Okay, so he showed us where to attach the red wire to the center off the magnetic coil on the side. Yeah, so it's looking like the wire out of the bottle attaches to beside it, only to the gravitational coil wire.
Yeah, you got to keep in mind where the coils are connected. You got a red and a blue, and that's your interface. That's where the two wires are connected together.
Yes.
So you'd have your lead GANs going to the magnetical side of each coil, and the outer bottles with your various different GANs goes into the gravitational side of each coil.
Okay.
And I mean, this makes sense to me. I can see the flow in it, but again, I'm not absolutely certain if this is the way Vernie's doing it in the Philippines.
Because it's easy to try.
Certainly is. Did you grab a screenshot, Lee?
I actually took that off. I already got that, but
Oh, okay.
or I can come back to the video here and get it. No problem.
All right.
Thank
All
you.
right. No worries. No worries. I asked Vernie, I sent him a note. I asked him about it if I could get the documentation so that I could replicate here, and he says he's not going to release it until he's certain that it's right.
Okay. One other thing, if you're looking for bottles like this to make one of these, I ordered a case of these off a company called Uline. It's the cake company that sells boxes and bags and bottles and all kinds of packaging stuff. Because I was having trouble finding enough, bottles to work, because I was eventually planning on making 4 or 6 of these things. So I ordered a case of those bottles. They're 4-ounce bottles.
I just went to the dollar store and to the kids' craft section and bought a pack of watercolors, and the bottles are exactly the right size.
Ah.
And like a pack of bottles is $3, and I got a pack of bottles full of paint that's $3. So worked out pretty good. But
Okay.
give you an idea of the sizes, I think you're using the same 14 gauge wire and 18 turns, right?
Right.
Right. So I don't have enough light, but that's the bottle, and that'll give you an idea of the size.
Let me make sure that spotlight so people can see it. Just a second, John. There it is.
Yeah. Okay.
Yep, that's a smaller bottle. That's
yep.
What would that
And
be? About a 2-ouncer or what?
I don't know. I didn't measure them, but they just come in packs like this, and I just took it to the sink and dumped the paint out because I really don't need a whole bunch of water-based paint. But the 18 coils, it's about 1.5 inches. These bottles are just short of 2 inches high. And the other coils, again, the coils that go in there, they're 18 turns as well, and they'll fit in just perfect.
Looks good.
Yeah.
Do they have
anyway,
a nice?
Lots of options. Just like, don't limit yourself. Don't think you have to go and spend $2 a bottle. You can just go and scrounge around and hit the craft stores. You'll find what you need.
Yeah, these were 79 cents each. These bottles, so, plus I guess some shipping on that. But
right.
$1 a piece, say.
Okay, put you back on the top. All right, there you go. Yeah, it's just there's been a lot of people. I get tech support stuff coming in all the time, going, "Well, is this the right way? Is this the only way? Is this the way it has to be?" And Mr. Keshe has been adamant, saying that there's as many ways to do these as there are stars in the sky. So don't limit yourself. Don't think that there's only one way to do this, because there's a million ways to do this.
There was a question in the chat here about whether it matters with the wire connection. Amanda Chim says, why do they not just connect to the closest wire and instead go over an extra wire? It's confusing. Zane says, no, it's not. You're just overthinking it. And Amanda Chim says, so would it not matter if it's connected to the closer mag wire? I think I would have an answer to that. And what would are you going to show something about that, Zane? You mean?
Yes.
Okay.
Yes.
Well, let's have a look. Sure.
All right, rock and roll. Hello, gang. Love y'all.
Just a second. I'll get you zoomed in here on the second screen. There we go. Okay.
Ooh, spacey.
This this generator is the most unbelievable thing I have ever built in my life.
If you can hold the camera really still, that would be better.
I'm trying.
Yeah, you need a tripod desperately. Okay, okay, that's good. Keep trying there. Go ahead.
Okay, but I accomplished it today at 3:21, and I couldn't believe the sensuality that came out of it, and the warmth, and the intensity of the field. It's just completely amazing.
I've noticed you got dissimilar wires on your
I used a 12 gauge aluminum wire and 14 gauge copper, and to create a gradients, and inside the the center ball is the main coil, which is counterclockwise, or the opposite of the star formation coils. And it like it almost what it's doing is the outer balls are feeding into the lead ball, and the lead ball is punching it back out, and it's just a constant flow. It's unbelievable. It's really amazing. Really, really amazing.
Yeah. Yeah, but I think to answer Menachem's question, the reason why we're jumping wires is to create that vortex, to create that spin within the field, and it's the spin is necessary. You need to have it.
So in that sense, it's a plasmatic circuit rather than an electric circuit. Electric circuit, you just connect the shortest route basically, but in a plasmatic circuit, you might want to twist the wires a certain way or direct the flow of the plasma a certain way.
Right.
Right.
Yeah. Zane, try that. One thing that Vernie was saying when he was playing with his is that they work really good in cars. So try it in your car.
I remember him talking about that. So I went and I started my truck and I let it warm up, to see the kind of gauge the vibration of it, and tried to walk away from it. But I mean, the further away I get, the noise would dissipate. So I mean, I'm kind of alone out here doing this by myself, so it's hard to gauge anything in that aspect. But like I said, I've kind of just been astonished and really dumbfounded by the sensations and the intensity of this reactor.
So what does it feel like to you? What do you mean by sensations? And so how do you feel? What parts of your body?
It almost wants to breathe for me and pump my heart for me. It's so weird. It's man, ever since it got cranked up, it's like I've been shaking ever since. Yeah, it's really, really intense.
We can see that in the camera. That's why you need a tripod, buddy. We can pretty much see your heartbeat in the telephone. Interesting, actually. Maybe it's the heartbeat of the unit coming through in a way.
No, it's me probably.
Well, I mean, people. What do people think? I've never seen a video shake in this manner. It's not just it's funny.
I'm nervous, I think.
Yeah, maybe that's it, but it looks like a heartbeat to me. I'll buy it. Anyway, go ahead. So you feel this energy inside of yourself from it.
Yeah. Can I say something that's kind of well, it's kind of foul, but it's not. Whenever it got started, it was almost orgasmic. The amount of energy, the pure energy that started flowing through me, it was amazing.
Okay.
Really, honest to God.
Well, we can understand that in terms of, for example, the work of Wilhelm Reich and so on, orgone energy and that kind of thing, which is very much a sensual, type energy.
It was very, very sensual. Very sensual.
Interesting. So you've got the three kinds of ganses there. That looks like, was it a paste or did it start crawling up your central electrode?
No.
There?
I took some hot glue, and I had some dry gans of each, and I made a real thick consistency of it and put it on the bottom of the coils, because I was thinking of the way the body's designed and how we go from matter to nano to mono to liquid and then back to matter. And I was thinking that if I was to put the solid GANs, they would be more like they would store the energy, and the liquid plasma would give it like a flow, so they would almost act like spark plugs to each other, pumping each other. And then with the gradients, I was thinking that the difference between the copper and the aluminum, it would give it that jump, you know, that uh,
Yeah.
that
The gradient, like you were saying, the
yeah,
yeah, the if it is in rotating magnetic, a magnetic gravitational field, essentially a plasmatic, rotating plasmatic field, then definitely it would seem like it would have more oomph to it with the gradient between the aluminum and copper.
but it's
We
amazing.
need a visualization tool. I'm wondering if this, because this is so strong, if something like a compass would show a difference in the fields. Got to have
Yeah,
some way to visualize this.
Or
I
another
love
way might be a steam vapor, for example, or some sort of Gans water vapor around it. It might show certain shapes in the vapor or something like that.
That's right. I'd be curious to see what that would look like if it was frozen. But please don't do that. It's gorgeous. That's a beautiful work.
yeah. Thank I gotta mention something to y'all because two really awesome phenomenons happened yesterday as I was working on it. I was about halfway through, and I had this like time lapse where um, someone from the Keshe Foundation, I, the artist guy, I'm not sure what his name is, but I seen his face and he was talking to me, and I had already built this. It was already built. It was finished, and it was like deja vu, but it wasn't deja vu. It was like a time lapse or a sense of the future and some sort of link to communication. It was really, really bizarre and awesome at the same time, and it happened twice. The second time was more like a thought, um, and the sensation, and uh,
Did you
I don't know.
did you
There's something up with this, man. There's something with this the field transfer or something
well,
that's connected
Kesh talks
that's
about
connected.
instant communications, for example, and that seems
Yes.
like a type of instant communications, and also the idea that as a species we're becoming more telepathic. Humans are becoming telepathic, which is the natural state of other beings of the universe, and they come to planet Earth and go, "What's up with you guys? You're not telepathic. What's the matter?" you know,
Yeah.
and and so I think that this is part of our graduation into the greater universal community, is the idea that we learn to become telepathic, and eventually it'll be no big deal. It won't be like, oh my God, you won't believe what happened to me. I was in communication with this being, and it's just like, yeah, so.
Yeah.
and tell me the good part. What information did you get?
Yeah.
What did you receive any information or some sort of, was there an interchange of some sort with this event that took place? Obviously you were affected by it and you thought something was really special about it. So but perhaps we can find ways of communicating, for example, to get information on how to improve our devices to make them even better. We should be able to communicate with them to be able to get that information. I mean, people do that
Yeah.
just with machinery in terms of your car or whatever. A mechanic will communicate with your car in many different ways. He could be hearing things that you couldn't hear, not you, but other people might not be able to hear. He might be seeing things, smelling things, and maybe communicating on his computer besides, and the communicating with the computer of the vehicle and finding out that information. All these different realms of communication, and some of it is more or less intuitive. You just more or less feel there's a certain vibration that's not right in this vehicle, and you sense how to correct it, or sense that it's a certain part that needs to be replaced. In a way that's communicating with the mechanical machinery. But with this realm, it's a little different. It just takes the whole stakes up a notch, and you're communicating with plasmatic entities, and that means it's much more universal in the way it operates, and much more well, it's just in a whole different realm. Like you're in the realm of feelings and sensations and so on, rather than more of the physicality realm.
Yeah, I added bone marrow and my blood to the center.
Ah, okay. Probably not your bone marrow though, right?
No.
Okay, well that's interesting. I wonder whose bones you're connecting with.
Next week, Zane will come on and tell us he's got 400 cattle wandering around his house.
He'll come on and go, moo, 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 no, moo. Yeah, and we'll go, uh-oh. No, I don't know. It's interesting, that's for sure. Thanks for showing.
Yeah,
and so, are you going to do anything else with this, or just let it sit as is, or?
No, I'm gonna do some. I'm gonna take it with me on the road tomorrow.
Okay.
See how the truck. I've been adding CO2 water to my gas tank also. You know.
Oh yeah.
And
does it have a name?
I don't know, but it's a she.
Okay. Yes, I should say it in its presence, in her presence. Well.
Thank you, Rick.
Yeah, let us know how your road trip goes, and maybe we'll hear more about it next week. You could do a video, make it into a real event. Strap her into your passenger seat. Make sure she's safe.
Yeah.
So on. Great. All right. Thanks, Zane. All right.
Very, very cool unit.
Pardon me? What?
Very cool unit.
Yeah. Okay. Anyone else have something? Lee, did you want to show something else here with your unit, or were we done with that for now?
No, I think I'm done unless we got some questions.
Okay.
Well, Manicam in the chat mentions that he's thinking of going to a larger unit, making it considerably bigger. And one thing that we found out, particularly with this plasma technology, is bigger doesn't mean more power. Just because you add more stuff to it doesn't necessarily mean it's going to work better. All of the things that we're working on that work really good are super, super simple.
Yeah, good point, John. That's a good point.
I mean, I don't want to dispel him from experimenting. Certainly experiment, but don't think that you make a 64 unit with nine bottles around it. You're going to have, a exponent of 3 times the size of the field. Chances are it's going to be, pretty close to the same, but just really more complex.
Yeah, there's some theories that if everything is put in exact places, like placing in a geometric pattern, the bottles or the reactors, then maybe that's a more magical way to get more power, lift, etc., etc. And there might be something to that in some of the more advanced stages, but I think where most of us are at, to not get too complex would be probably a good idea.
Well, it's the stuff that Mario's been coming up with his relating it to music, and the precision matters. You can see it in that mathematics. That if it's out a little bit, you're deforming a portion of the field. You're not going to get that nice resonant balance within it. So yeah, certainly precision is going to eventually going to become quite critical with this. But right now, with the stuff we're doing, if you can get the equivalent of 100 kilowatts out of your device, why try to go for a megawatt? What's the point?
Mm-hmm.
We're not using the energy yet. So all we're doing now is collecting it and learning how to collect it. Once we figure out how to use it, then we can worry about, getting an extra 5% or 10% out of the system.
Yeah, it'd be nice to see more duplications and replications of actual working systems that are showing something as a standalone generator. Anybody online that has one now can certainly come forward, and it'd be great to see. Hint, hint. We have the Keshe Plasma Reactor group has kind of been the whole idea for the last 3.5 years or so to create these reactors. I mean, there's, like John was saying earlier, there's literally infinite number of different types of reactors that could be created, but it would be nice to see one that's actually producing some valid power that we can measure, or something that we can see. Besides, feeling it and so on, can we show, light or heat or generation of power, or some sort of effect? Preferably replicate what Mr. Keshe has shown, and Douglas and others are doing now, or take that to the next stage, basically, which is partly why we're in this group and do the things that we do here.
Well, I've got a feeling that this new style, excuse me, this new style reactor, because it's entirely plasmatic, it's not converting to electricity anymore. When we start working with that in a star formation, then we're going to really see some output from this. We're going to see some physical effects.
Yeah, that makes sense. Mm-hmm.
Because up till now, we've sort of been kind of on the fence between electricity and plasma, and converting back and forth. And when you throw that matter state in there, it diminishes the plasma. It throws the fields for a loop. They're not a nice resonant circuit, for lack of a better term. And now that we're stepping into the purely plasmatic systems, I got a feeling that once somebody gets that balance just right, they're going to have some pretty cool effects come out of it.
Yeah, good point, John. Just wanted to get the design up so we have some inspiration to look at here. There's the basic hybrid maggrav plasma generator, off-grid plasma electrical system. This is the prototype setup, and many of us have been looking at this and experimenting and trying to come up with these different parts to play with and so on. Is there any new information we can go over about this that people might have to add to the knowledge, as Mr. Keshe says?
Not really. There's been a lot of people that have been playing with the starter circuit, trying to get it going, and destroyed an awful lot of little pond pumps.
It's caused a surge in pond pump sales temporarily in the world.
Yeah, I'll tell you guys right now that these pond pumps, they just don't last very long driving them like this. There's probably a way to make them work a little bit better. If you can't get a pond pump, look for a washing machine pump. They're almost exactly the same design, and they're a little bit more robust. I think I mentioned last week that I was working with a fellow named Gerard Morin, and when you run these pumps off a DC motor from a battery, you get a completely different kind of energy out than you would if you had it hooked up to, say, a corded drill or a Dremel that's plugged into the wall. I don't know why, but the output effects of it are completely different. Now, there's been a little bit of talk about the compressors. Some people looking at different types of motors to use on these instead of just the compressors. And I think if you stay within the parameters of that compressor, which is a certain type of phase, start run windings, the basic design of that motor, you should be able to just use a motor for this and not necessarily a compressor. I doubt the load on the motor is really going to matter too much, because the whole purpose of having these two motors on there is to create this magnetical feedback, this 180 degree out of phase feedback loop bouncing back and forth between these two. I've been talking to a few people who are in the process of building these. Nobody's up and running quite yet. Hopefully they'll be running tomorrow. Maybe they'll be up for the workshop tomorrow. That would be nice. And my friend Boss in Sweden, he's been just doing tests with the starter circuit, measuring the output, spewing it on an oscilloscope. But he hasn't been running it off a battery, so he's not really seeing the crazy effects that these things can produce. I mean, the test we did at Gerard's place, we had the washing machine motor on a DC motor running off a battery, 18 volt drill type battery. And then that was running into 2 step-up transformers. So we were getting 20,000, 30,000, somewhere 50,000 volts output of this. And we were getting field effects for, 8, 10 feet away from this thing. And when we hooked it up to something that's plugged into the wall, we got no field effect whatsoever.
That's interesting. I've got you mentioned a washing machine motor, and I'm wondering...
Not the washing machine motor, the pump.
Oh.
It's the same sort of pump. It's a permanent magnet rotor with stationary field.
I got this one here, for example.
Yeah, that's not what I was talking about.
This is 110. Normally it would have a pulley on here. I just stuck this little one on. And it's got 3 wires. I guess there's a starting and a run circuit, and plus a ground. And it's made to run with a capacitor, 20 nanofarad or 20 microfarad. Is it nanofarad? I guess it is. Capacitor.
That's pretty small.
Is it 20 nano?
It would be a microfarad. You're dealing with low frequencies, so it would be a fairly large capacitor for...
Yeah, it says on here. Let me just get that straight. Yeah, microfarad.
Yeah, a 20 nanofarad capacitor. You're up in gigahertz frequencies with that.
Yeah. So, yeah, interesting. I'm going to try to run it and just see what happens, see what kind of output it has. I tried it at lower RPMs and got just with a drill, and it started to put out some AC output, and also I got up around 20 hertz or something like that, but I needed to run it faster to get the hertz up. So apparently...
I think if you take that motor and you drive that motor with another motor, trying to get output out of it, you're going to wind up with a very similar thing as the QEG, which is basically a parameter pump. And the inductance is constantly fluctuating. Problem with the QEG is they're getting reactive power out, where the voltage and current are out of phase, so they can't do anything with it. You may wind up with the same sort of problem with that, because there's no actual magnet there. All you're doing is you're changing the impedance around each coil, and it builds and builds and builds until that impedance actually starts generating electricity. But what we found experimenting with the QEG was that the output electricity, because it outputs a massive amount of electricity, but the current and voltage are out of phase, so we can't use it. We have no way to do anything with it.
And what should the phasing be for the best magnetic pulse to start our starter circuit, as we've seen on the diagram there? Let me get back to that.
Well, the pond pumps, they have 2 coils, so they're basically you're getting almost a pure sine wave coming out, but they're very like I said before, when you spin that magnet with something that's not attached to a ground or the grid, you get some bizarre effects coming out. And I've got a feeling it's that little bit of weirdness, not so much the sine wave voltage current that we would expect to see, but the transients, the extra little bits that are in there that are actually making the difference in this maggraph circuit. Again, don't quote me. I'm not absolutely certain because I haven't built one or tested one myself. I'm waiting for the next iteration that doesn't have the fridge compressors in it.
And what do you think would that look like?
Well, the first test that they're working with that I saw was basically two of the same maggrav coils, but wired back to back, wired in a figure-8 configuration.
Right.
And
Yeah.
whether that's going to function, again, I don't know. It was just something that they showed in passing and said, "This is what we're working on. We don't know what's going to happen with it." So we're still waiting on that.
Yeah, I was thinking of even two resonant pancake Tesla coils, and one would resonate at, say, 160 hertz, and one would resonate at, say, 100 hertz, and you would subtract the difference to give you the 60 hertz resonant factor or beat frequency between them.
Yeah, but if you look at the way these motors are wired, they're wired 180 degrees out of phase. So when one's firing, the other one is supplying back EMF. How are you going to get your two resonant coils producing a heterodyne that's going to incorporate that back EMF within the same phase as the forward energies?
Well, I figure that if one's phased at one frequency and one is phased at another frequency, you build them to naturally resonate at their particular frequencies, and you should be able to subtract one from the other by just hooking them together, and end up with a resultant frequency. In my little mind, this is what I'm hoping.
No, I can see what you're talking about, and you know, I like Mario. I'm a musician, so I understand heterodyne and beat frequencies and that sort of stuff. I'm also quite well versed in RF. I used to build radios with my dad when I was a kid. And,
Like
but
this
you
is
know,
similar to RF, but it's actually magnetic pulse, which is a little different. Like for example, the flat or Tesla pancake coil. It's called a pancake coil or flat bifilar coil in particular. It has a self-canceling uh, type of magnetic field on it. So like normally you have a coil, it tends to be like it has impedance to it due to the magnetic field builds up and it essentially blocks the electricity at certain frequencies and so on. But with the bifilar Tesla coil, because the windings are beside each other and moving in opposite directions, it multiplies the fields. It has some sort of special fields it gives out. I know it does have magnetics, but it has a different type of magnetic field than a regular wound coil, is the idea. So I'm wondering if it is more attuned as such to magnetic pulses rather than the electric that is in most circuitry that that people focus on is the electric effect, moving electrons around and stuff, instead of a magnetic pulse going through the circuit. So I'm thinking maybe that's what we need, is a magnetic pulse that is the heartbeat, and not an electric pulse, but a magnetic pulse.
Yeah, I'm still heavily stuck in the matter state with this. And well, we're dealing with two electrical motors, so yeah, there's a lot of matter state interaction
Yeah, it's
here.
a couple of fridges. I mean, after all,
Yeah,
how much more matter state can we get in a way? But on the other hand,
but the magnetic interaction that I'm seeing between these two motors, say the blue one fires while the red one is on its rest state because they're out of phase. Yet in that rest state, the red one, as the magnetic field collapses, it's going to recharge that capacitor. Then they switch over, the capacitor fires again, gives the red one a bit of a kick while the blue one is in its discharge state where the magnetic field is collapsing, creating back EMF, which is going to go in, feed the red one, charge the capacitor again. So with your 2-bifilar pancake coils, you would need to have, well, first of all, a lot of copper, because you need to be able to, I'm pretty sure with this type of circuit, you're going to want to be able to capture that back EMF of the collapsing magnetic field and feed it into the second coil to help drive that second coil. So you're kind of making a runaway ring modulator, sort of in, kind of a sideways view. It would be sort of like a runaway ring modulator where you're limiting the runaway through the capacitors and what load you're putting on it.
Starting to sound more like CERN all the time here.
Yeah.
I think that's where the drawing comes from. It's got the starter circuit where you inject the beams into the circular grid here, and yeah, okay, well that's interesting. Any other feedback, questions, or comments about that? Shall we move on, or what? Menachem says something about I can show you how. Okay, do you want to show us something? Do you have something now you want to show us, Menachem? He says, okay, sure. All right, well, I'm not sure.
I don't see that he's got a microphone. You'll have to set up a microphone in your Zoom, Menachem.
He's got a microphone, I think, but no video, it looks like.
Oh, sorry. My mistake.
Okay, well, you'll be able to talk at least. I don't know if you'll be able to... well, if you can do a screen share, if that's what you want to do, share a photograph or a screen share. Otherwise, you need to get your video hooked up with Zoom there. How would you like to do it?
Oh, there's a camera now.
Ah, okay. Things are popping into place here.
Now I'll get you to unmute. Make sure that's all working.
I'll ask to start video. I think that's what we need to do there.
Okay, and we got a video.
Let me stop the screen share. Whoops. And okay, we have a black picture so far in your video, Menachem.
Peter says, no, not the screen share.
Okay, still looking black. Oh, we have something coming
okay,
through. Here we go.
We got a picture now, but we have no audio. And Rick just unmuted him. I don't hear any noise.
Hello, there we go. We have a picture coming through. It's see something held up there. Let me get this zoomed in here with the live stream.
Okay, that looks like one of the fridge or the washing machine pumps.
Indeed. Front-loading washing machine pump.
Yeah.
Okay.
Yeah, not all the washing machine pumps are created equal. If you look at Gerard's videos on YouTube, Gerard Morin is his name.
Yeah, I've seen it.
He goes through and explains what you need as far as the pump goes.
Right, I've seen that.
Okay.
I've seen the video.
Okay. And just in the 3 hours we were there, I think we burned up 2 of them.
Yeah, you guys did a great job on that video. No. Inside the washing machine, there's also this part.
That's a flow solenoid, right?
What does this do?
That looks like it turns the water on and off for the fill.
Yep, I think so.
Right?
So it'll have a little sort of electromagnet valve in there, which might be interesting, but I don't know if it's useful or not in this circumstance.
You can make an interesting fountain out of it.
Hang on a second. You see the way this is designed to be used in a washing machine, that the electricity would go in to the cables and would drive the magnet to turn. Jared Moran is using that in reverse engineering.
Yep, that's
He's driving a motor, turning this, and then drawing energy out of the wires instead of putting energy into the wires.
Yep, that's exactly the way the starter circuit on the blueprint is drawn.
Okay, if this part can be reverse engineered the exact same way, so that water would pass through and it would feed out energy.
Oh, no. That's just a valve. That's just an electrically operated on-off switch for the water. That's all that is. If you hook your garden hose up to that, and no water would come out. But if you energize the two pins on that, it would start squirting water out. It's just a valve.
If you put your garden hose on that, are you able to tap electricity out of this?
No.
Like
No,
Jared's doing with the pump?
No, it's just a valve. That's all it is.
Oh, it won't do that?
Okay, the pump is different because you've got a magnet. That center spinning piece is actually a two-pole cylindrical magnet turning inside of two coils of copper, that's the main
two of these.
How a generator works.
Two of these. Two different kind of these. Okay, excuse me, forgive me. I misunderstood this. If this part would work the way I think it to work, which you're saying it doesn't work that way, then it would, when I put the water through here, it's going to give me electricity on these two pins.
No.
If I take that electricity and I feed it into this pump, I can keep the water going with enough of these forever.
Yeah, no, the only part
it doesn't do that, then it doesn't do that.
Yeah, the only part on the washing machine you can spin with something and get electricity out is going to be that pump. The other ones are just valves. They just turn the water on or off. You put water to them, they won't work unless you put electricity, and then the water will squirt through. But there's nothing.
What I understood, it was like 50 or 60 hertz, meaning it would balance itself and give its own frequency when the pump would pump the water through, and it would give out energy.
No, you need something to move that magnet in the coils. It's the moving magnetic field. When the magnetic field cuts through the wire at 90 degrees or perpendicular to the wire, then you get a current induced in the wire itself. That's why with just the magnet sitting in the pump, not moving, you don't have any electricity out. But as soon as you move that magnet, then you have electricity. So for the valves to work, you would have to find some way to oscillate that valve.
Okay, excuse me, I finished with my demonstration. That was just a part, and I've misunderstood it. So my apologies.
No problem. That's why we're here. Thank you for showing, and we're happy to help out to figure things out like that.
Thank you for clarifying and explaining this misunderstanding of mine.
Okay. There is a way maybe that kind of thing can be used, and I can show what I've gotten into a bit here, which is I took one of the little aerator, let me just get my audio, make sure it's on here, and I have to get my other screen up and so on. Just a second here. And there we go.
Is that an air pump?
Yeah, this is just a regular, little air pump housing. It normally you have a thingy on it to stick your air hose on. It pumps out air. So I took it apart thinking, well, I wonder what's in there. And it does have a tiny little air pump thingy. That's sort of, it goes like this, and it's got a little electromagnet doohickey here that makes its metal thing here basically wiggle up and down to make the pump air. But this is just a very simple transformer, right? Essentially like an electromagnet.
Yeah.
And it's just the way this metal thing happens to be supported, and it makes it go back and forth. Well, I figured, what if I use this and a rotating magnet on a shaft to create a pulsating magnetic field back through the plug. And essentially, it should create at a certain frequency that would create a current, and might be enough to be a jump start for the system. I'm thinking, just because
if you put that over top of your Tesla turbine with those 6 magnets spinning on it, you would get you'd get enough out of there to knock you across the room.
Yeah, it would probably generate quite a bit of voltage through that. The amperage would be low. It's still probably enough to knock you. You're right.
It would hurt. Yep.
Yeah, it's interesting. So that much of a pulse, if it hurts, then hurts. That's the secret. If it hurts, then it's got enough cycles to work, enough plasmatic juice to work. Maybe that's the secret. If it doesn't hurt, then it doesn't work.
Yeah, I don't think engineering jokes are going to go over very well.
Yeah, probably not. It's a pain and plus hurts joke. You have to get both ends of that. But in any case, it may be possible to use. It might be too weak, or maybe it's not the right pulse or whatever, but it's cheap and easy to try.
You could get really high frequency out of that with your Tesla turbine, because that thing spins at what, 14,000 RPM.
It can. I can also run it on tap water pressure at up to speeds up to maybe 2,000 or 3,000 RPM. And generally maybe more like 1,200. It's got 6 magnets on it. So, at 2,000 RPM is like 12,000. Yeah, 12,000 pulses per minute.
Per minute.
So that's what, 200 or 200 hertz?
Yeah, 200 hertz.
So that'd be right in the ballpark. Just have to slow it down to whatever it is that 6 magnets. It should be 10, 100,
For 60 hertz, you'd want 3,600 RPM?
No, less than that, because it's 6 per revolution.
Oh, that's right.
1/6 of that. 600? 600, I think. 600 would be 3,600 hits per minute.
60 times
600 revolutions per minute times 6 per revolution is 3,600 hits per minute, which would be 60 cycles.
60 cycles per second times 60 seconds is 3,600 cycles per minute. Divided by 6 would give you, 600.
Yeah, so 600 RPM, which is easy to do with the faucet water pressure. I was thinking of that today. I'd just be able to turn on the faucet for 2 or 3 minutes, which some places is a waste of water, but you can always put it into a container. Just the faucet water pressure for 2 or 3 minutes might be enough to jumpstart the Maggrav plasma unit generator.
Yeah, I'm wondering if your Tesla turbine has enough torque to be able to overcome the cogging of those magnets, though.
Well, it's able to do it on other devices. I've set it up and able to light an LED and so on from the magnetics without slowing it down. This is a rather big unit. It might tend to slow it down a bit. You can always hold it up a bit from the surface where the magnets are rotating, and it's less drag that way. So it can be varied as far as the torque and drag goes. But that's an interesting alternate way to approach the situation, you might say.
And also because of your 2 poles, you'll be able to tailor your 0-point bias depending upon which pole you have closer to the magnets. You could either have a negative pulse or a positive pulse, or if you had it sideways, so it passes one pole and then the other pole, you could at like a double, like a very, like be like a heartbeat, a very sharp pulse, positive, negative, and then a dead spot, and then another sharp pulse.
Yep.
Interesting stuff to play with.
Yep.
Hope you
You
got an
could have
oscilloscope.
a negative and then a positive by having north, south, north, south, north, south instead of all north up on the magnets like I do now as well. So there's lots of options that way. If we can
Yeah.
prove that a magnetic pulse is important to be the heartbeat of the system, is that what it requires, or is it some other thing? Is it a more of a plasmatic effect that we need to achieve to make that pulse, or is it so simple and easy as just a simple magnetic pulse?
I have a thought about that. If I can come in here. Hello, everybody.
Okay, yeah, it's Mario.
Yeah,
Yeah.
you're really quiet, Mario.
Oh, okay. Better now.
Nope.
Not really. Maybe the computer will catch up to you there.
It's my internet connection. I'm in a hotel in Shanghai. Can you hear me? Okay.
Yeah, more or less. It's a little quiet, but we can hear.
Okay. Okay. I was thinking about the drawing last week with Sandor had it, and you had the two compressors, and the compressor and the motor, I guess it was, with an R and an S, a run and a start, a start and a run, and a start and a run. You have to connect it the opposite way, right? There's something about, okay, once those connect, you have that infinity loop. I think the whole problem with the MagRav units all along has been, unless you have a feed of the right field strength, the right pitch, that 50 hertz, 60 hertz, 220, 110, whatever. Yeah, there you go. Okay. That it, once you unplug the MagRav unit, it loses that sample, whatever, and the field collapses. And it's just something about when that click happens, that the starter motor turns off and it goes to the run motor, that it disconnects. And once you have that click, it's a way of starting it and keeping the field from collapsing. So it's not just to get the right fields. That's been fairly easy. It's to get it to when you stop it to have to keep the field from collapsing. So there's something about using the compressors that has that start, then it clicks off and isolates the circuit. Now you've got that field isolated. Now you can turn everything off. You still have that infinity loop. So there's something like that going on in there. It's not just getting the replica of the right fields and right hertz and all that. It's keeping it from collapsing. So it's not. Yeah, does that follow? Make sense? Anyway.
Sure. We've got Peter, who's in the chat, says, get rid of the compressors. There is a much easier way for the infinity loop. Okay, well, maybe Peter has something he wants to say on that topic now. If you want to, Peter, you can open your microphone and speak if you like, if you have something to comment on that. Or I'll unmute you and you can try there. Hello, we can hear you, I think. Do you want to talk, Peter, or no? I can. Oh. You got some feedback going on there. I think you'd have to turn your speakers way down in order to speak on the microphone. It's feeding back pretty bad, so I had to mute you.
Yeah. Well, in the meantime, Don Graham says he's got something he wants to show us.
Yeah, maybe we should go there and check that out. And also, Umar says, Keshe Taiwan has posted an image of some coils which are expected to replace the need for a compressor. And
yeah, I think that's the two MagRav coils set up in a loop, if I remember right.
Okay, well, we could have a look at that perhaps as well. Let's Don had something to show first, so let's go over to Don and see what he has. You want to go ahead, Don, and show what you have to show, or whatever you'd like to do there? Let me stop my sharing. Hello, Don. I'll unmute you and see if you can see if there's something you want to say there. Hello? Hello, Don. I'm not hearing you. I'm not sure if you... I've opened your microphone, but we're not hearing you. Okay, so maybe we'll have to do something else here. I'm not getting... I'm not getting anything happening there unless if you can do your share your video or screen as you wish there, Don. Let us know.
Okay, I had a quick look at that Facebook page that was in the chat, and it looks like it's sort of a combination between a delta configuration of capacitors and a ball of GANs in the middle. It's kind of hard to see right off the bat, but who knows? Maybe it'll work. We'll see what happens in the next little while.
Is that the stuff in the box there? Is that what...
Yeah, the second box.
Okay,
You
let
need
me
to
show
kind
that.
of pull your eyes out of focus a little bit, and then it becomes clear. But he's got two capacitors on each leg of the delta, and then one capacitor on each leg around the outside, with what looks like a ball of GANs in the middle.
Oops.
At each apex, it looks like it's just a ring.
Hold it, we got a screen share going on here. What's... oh, it's Don Graham's
Holy
screen.
cow.
Okay, Don, one thing you don't want to do is share your whole screen, your desktop, because people can see all your applications and maybe private stuff. But you can open a picture or video or whatever you want to share, and then do that share instead of sharing your entire desktop. You can share a window rather than the desktop. It'd be better. So,
Well, we know he's got a camera. It should interface into Zoom. Zoom picks up pretty much all the cameras.
mm-hmm.
We're going to have a show about how to run Zoom, Rick.
Well, it is good for a show, all right. It's kind of tricky, but...
And Mark's in. All right.
And I see Chad is in the live stream chat, and he had a question about whether the fields were previously, whether the fields were counter-rotating with that device, and about the new wireless generator. Counter-rotating fields. I believe there are counter-rotating fields involved.
Well, the magnetical field and the gravitational field are counter-rotating. I'm not sure if that's what he's referring to or not.
Okay, and I'll just, while we're waiting for something or another, I'll just do a screen share of that previous picture that you were talking about, John, showing the... You were talking about that lower box, is that what you're... or the upper one?
The lower box.
Mm-hmm.
The upper one looks like just like a capacitor array, but if you look at the lower box, the top that's sort of half hidden under the flap, you can kind of see a delta configuration of capacitors there.
Yeah.
And we know they have very interesting effects. They can do some strange things too. But it's not clear enough to see just exactly what's going on here. Almost looks like they just took a pile and threw it in a box, but I'm sure it's... Well, no, there's a little more order to it than that, but I can see clearly enough to see how it's wired or how any sort of flow would happen within it. But this is different than the one that I saw, because the one I saw was just essentially two double maggrav coils facing each other and wired in a figure eight pattern, and that was one of the things they were testing.
Okay. Okay, we've got Peter who's switching to his headphone and stuff. Let me see and get the latest. He says he's ready there. Menachem has a question about GANs and gold GANs. And Peter wants to show us some stuff from NREM Tech, which he says will easily get rid of the compressors and drastically improve the efficiency. Okay, so let's go. Okay, well, maybe we should answer Manichem's question first on the GANs, and then we can bring Peter in. We've got a question. Let me stop my screen share, and we can pin that. And get that up. Okay, so the question from Menichem is about putting gold on the outside, not to affect the original material, so you still have a gold plated or gold ring intact after, and just placing it in the sun. Would it make gold in the water? So he's saying, like, similar to creating the GANs materials using the plates on the outside of the container. He's hoping to keep his gold ring intact and make gold in the water. Reasonable thing to want, because you don't want to lose your gold if you're making gold. But on the other hand, what do people think? Is there some feedback on that? Seems...
I don't think the fields would be strong enough.
Right.
I would just say you have to give a little to get a little.
To get more, maybe, yeah. It seems like you'd have to have, well, first of all, your gold ring or whatever, but you'd also have to have some other gold object that's been nano-coated gold. It seems like gold plus nano-coated gold is the combination to create the gold GANs, at least. So it would make sense to have a nano-coated gold object and a gold object, and perhaps placing them together in some way, maybe in the sun. Maybe it would
Yeah,
make...
you need some way to release the plasma fields of that gold at the strength of gold, and then interact that with another field strength that would slow it down back into the matter state. I don't think just 2 pieces of gold outside of salt water is going to do it.
Right. So what if, for example, the gold was in salt water, but it was also had vinegar in it, let's say, and vinegar and salt combined to make hydrochloric? Maybe the hydrochloric would have enough oomph to dissolve some of the gold or make it into more workable fields that could be interacted with the sun. We do know that the sun interacts with nano gold, so if the gold was in a nano state and in the salt water, there's a good chance it could interact with the sun and maybe do some special stuff. For example, nano gold that's in, I've mentioned quite a few times, but I'll say it again, in the stained glass windows of the medieval times, the sun would go through the nano gold in the stained glass window and would interact with the air to create ozone, which is a very effective form of pulverizer. Essentially, it decontaminates and isolates the air pollution and that kind of thing.
Which leads me to think, looking at it from a plasmatic standpoint, that the plasma of the sun interacting with the fields of the nano gold is creating oxygen.
Well, it converts the O2 to O3, essentially. And O3 is an ionic gas that is extremely reactive. And it will react with any air pollution that's close to that window and immobilize it. And, what do you call it? breaks it down into its basic components. Same as heavy metals and that kind of thing. It'll tend to immobilize them.
Yeah.
What do you
And
got
it's trying
there,
to show
Mark? You're trying to show us something, and we see gold written on there. We should be paying more attention, I guess.
Nah,
Just gold gans, nothing
just
special.
gold Gans.
How did you make your gold gans?
Well, I made a video. We saw it last week or the week before, and I was just wondering if anybody else had made it. I know Manny wants to see it. He was desperate to see gold Gans, but it's relatively easy to make if you ask me. I don't know if it's made right, but I have what I have on the bottom of that cup.
And what color was that again?
It's that amber gold,
Mm-hmm.
amberish, and you shake it and it fluffs up. Yeah, I'll show it again.
Yeah, it's definitely not particulate gold because that would be considerably more dense than the water and it wouldn't float up into the surface.
No. Watch. I'll shake it. Here, let's shake it up.
Oh, good.
That's all right. It'll settle down real quick. It's gold. It's beautiful.
I've seen some other people get this similar color, and then some people seem to report a green color that they get in the fluid.
Yeah, I got the green color in the beginning. I thought it was polluted when I first started it, but it washes out once you clean it. I thought it was too hot. When you
Mm-hmm.
got to make gold with a little bit of power or a little bit of electricity. Wait a minute.
Well, some people are creating the nano plates first, so that you end up with two gold plates, and you put power in them, and one of the plates will naturally nano coat itself. And then you take those two plates, put them in the salt water, connect the plates with an LED, and wait for weeks, and you'll get gold gans that way as well. But you were saying you put a little bit of power in, like about a volt and a half or so, wasn't it?
Yep, like a battery, just a battery. And the way to do it is you get a pure piece of gold. I got a piece of a gram of gold that was untouched. You go to the wherever you buy gold, whoever wants to sell it to you, but you want to get the purest 99.9. I didn't touch it with any hands or anything like that. I took I cut it in half. That's what bummed me out the most. I can show you. It's still here. I cut it in half because it was a gram of gold. I cut it in half, and then I put one half. I kept dipping it in caustic solution, just dipping it, not leaving it in, just dipping it so that the surface was changed. Whatever you want to call it. Once you change the surface of the matter, now you have a gradient.
Mm-hmm.
It's simple. So, I did that 3 or 4 times, and then I just let it dry off, because then the white milky stuff dries on there, and that's the residue of the caustic solution.
Mm-hmm.
And that's all that's left on that little piece of gram. That's really small. So then what I did was I clipped it to my 2 alligator clips on my power supply, and the nano code to the negative and the power to the red to the non-nano code. And you just don't get the clips in there because you don't want the material from the clips in the water. You only need the signature. You just got to have the metal or the gold touch the salt solution. Once the metal touches the salt solution without, then the little whispers of the signature starts to drop off into the water. You can see it. It's as plain as day. One gives, one takes. And the green stuff that you were getting on the one side, I can't remember, because lead is different than gold. It's the opposite. But anyway, because you keep working with this stuff. But if you see green in the bottom of one side, I thought I burned my gold by doing that. And you didn't, it's just how the nano side, whatever way that the circuit goes, it gives a green hue to one side and the other side stays completely clear. And I made a video of it. I made a video of the gold. It's on my Facebook thing. But you can see that the gold, this stuff stays on one side, the green is underneath. And then once you wash it with CO2, that green stuff goes away. And this is what you get. First, you want to, because it's all salt in here, right? And then what you want to do is you want to wash that salt away with the CO2. So then you wash it away, just like Jackie said, you wash it away with the CO2, then you wash it away with the distilled water. Now it's pure. Now there's no variance. It's the CO2 cleared made all the poisons and whatever man did, the salt, everything. It just, CO2 does what it's supposed to do. It drops everything down, raises everything up. You keep washing out of the cup, and then you get a clear solution like this because it's distilled water, and then all the goodies are on the bottom. And like I said, we've been standing here for maybe 10 minutes, and it's perfect. It's down on the bottom again, completely clear. Does it make sense to you or not? Does it make sense to everybody or not? I don't know.
Yeah, I think so. I think that the CO2 is or the CO2 GANS water is a good way to clarify things and so on. Yeah.
If there's any poisons or any ill effects in anything you've done, the CO2 is our natural giving and taking. It's the perfect, CO2 is perfect, and it helps everything else. And I've been doing the pH, and this stays in the range of 7 to 6.8, 6.9. I did where's the other reading? I got so many readings, it doesn't even make sense to me anymore, but I'm having fun with it, but I understand it more. Mm-hmm. Like I said, I live in Detroit. I'm a painter. I don't even understand some certain things, but I hope this clears it up for Manny. You just go on my Facebook thing. It's really easy. You just zap it a couple times. You can see when your stuff starts getting ugly. You don't want to keep it running anymore. It's like a battery. I was going through batteries way too fast, and I bought this thing for $99, and it'll keep it at 1.5 like a battery, and this is what you get out of it. Don't go any higher than a battery because then you burn it. It's just the metal gets all weird looking. I've done it with zinc. I've done it with all the metals, Mm-hmm. So yep. You don't really want to go higher than 1.5, like a battery, like a AA battery. And you just got to take your time. You'll start to see the streams of it coming off. I did a beautiful lead. Look at this lead. And everybody complains. Everybody says, oh, lead is so giving and taking, and you should hurt yourself and stay away from everything. But boy, this lead came out beautiful. Can you see that? Mm-hmm. And the lead is at 9.3. And I'm holding it. It doesn't hurt me. It's in there. Like people are going like, oh, my heart really beats fast and mm-hmm. this and that. And it's a giver and taker, but it's an element that is part of our life. It's here. Don't be scared of it. Just like I made this week, it's all part of my whole experiment. Here's the lead. We need the lead.
Did you use nano-coated copper along with lead to make that?
No nano, no. You want to keep everything the same. So I did the same thing with the in the lead process. I did this. Let me take a minute. What I did with the lead, so I took the lead, one whole piece of lead. I cut it in half. I put one side in caustic solution, and I just kept dipping it with my little tweezers. dipping the bottom, dipping, because I knew where the alligator clips are going to be. And that's, you know, you don't want, if you put the caustic up all the way through, if you just drop the whole thing in it, it would be caustic everywhere. And then it gets on your clips, and then it goes up your clips, and then it's a mess. It's ugly. So I just kept taking my tweezers and dipping it in the caustic solution. 2, 3, 4, dry. 2, 3, 4, dry. Just take your time. Just go slow. Dip it, dip it, dip it. Here, do you want to see it? I'll show it to you. This is where all my goodies go. Where is lead, lead, lead? Where did you go, Mr. Lead? Copper, silver, lead. I should have my gloves on. Very first thing I should have on. But, dang it. See, I wasn't prepared for this because I got a lot of other stuff. But anyway, I'm sorry. I should have been a little bit more prepared. But like I said, Lee, just take your lead and just dip it a couple times so that your clips don't touch it, so that when, because I did all my stuff in small containers like this. Where's the tops? Top. Now I'll just grab the top. A top like this, I put positive, negative, and then it just hangs down with your little clips, and then you just bite the little ends, nano coat, nano coat, and then just, you know, put your salt water in here and just screw it up to the top. And now the metals are just hanging in there with your clips, you know, holding it. And once again, you can see on my Facebook thing how 1 point, or I start out at 0.50, and just to warm things up. And then you just keep adding till you get up to, you'll see, because sometimes you don't want the voltage to go over 3, because 3, and then it goes 4, 5, 6, and then it has to come back down. You don't want that. You want to try to keep the voltage at 3, 0, 0, 0, 3, and the the current at 0, 0, 3, and the voltage at 0, well, the highest 0, 1, 5, 0. Does that all make sense? You guys are smart. Anyway, you'll figure it all out, and you can see the video on. Anyway, let's get to the most important part. I am so totally freaked out right now because the energy ball is working.
Remind us what the energy ball is. Is that the big round clear ball that you have?
Yes, I did a little modifications because of what we've learned in the past couple of days and weeks and everything, that, you know, because I didn't want to do anything with motors and spinning and anything like that.
So when you say it's working, what does that mean to you?
I got motion.
Oh yeah, okay.
I got rings, I got water, I've got energy, and I've got slow motion in both balls. I never had the rings. I have 2 rings that popped up as soon as I filled the balls back up, because I changed a few things on them, because I just had some rings on the top, rings on the bottom, and I had all kinds of configurations, but it just laid there, and I laid there, and I didn't do anything. So I thought, oh God, I got to do something here. And we learned, and we thought, and we configurations of infinity loops, or, you know, we want the plus and the minus. Come on, keep moving, move, move, move. I kept thinking, well, we don't have a connection. So I didn't have any wires from the top to the bottom in each energy ball. So I took them all apart and I started thinking, energy from top to bottom, sugar, salt, sugar, salt. How are we going to get sugar and salt? Because they're positive and negative from top to bottom. Well, you dummy, you don't have anything connecting to it. You got to have some wires. Get some wires, copper wire, the 16 gauge wire. You made the whole rings out of 16 gauge wire. Why don't you have the two of them connecting? And then I started thinking to myself, because we were thinking now, because we want an infinity loop that constantly gives and takes in the water, back and forth. And I kept looking at the rings that I made from the top and the bottom, because I only made a single ring from, you know, in each top and each bottom. It's a single one ring, one continuous ring from beginning to end. And then everybody was going like, you know, like on some of the Facebook things and Golden Gate, you know, like we have clockwise and counterclockwise, and then we have to reverse them because of the figure 8. Well, we don't have to reverse it all. If you just make the wire in the right way, it does it itself, and I can prove that now. And it took me a while to figure it out because I didn't know how to wire the stupid thing, because it took me a while to figure it out. But anyway, I kept looking at the wires that I make that are inside the balls. So as you look at this, here, I'll get out of the way. Anyway, let's see. It's counterclockwise on this way. If it's a single ring, counterclockwise. And if you look at your ring, if you keep on going down the rabbit hole, it comes out clockwise. Does that make sense? Everybody?
Only if you're a clock.
Cuckoo, cuckoo.
A cuckoo clock, yeah. Well, yeah, this has been one of the enigmas of the coil. When you bend it around, it turns into a multi-dimensional wormhole. And
exactly.
Yeah.
It makes the infinity, the constant giving and taking back and forth to itself. So what I did was in my energy balls here. Hi, everybody. Hello.
Yes, they look lively, all right. So, okay.
They are starting to come alive. So once I started to think about it, we have to have wires to go to each and every one of them. So what I did was I figured out that in the loop, there's an in and an out. So what I did was I connected the out from the bottom to the in from the top, and the out from the top to the in from the bottom, which now gives me the figure 8. And since I did that, because I have all kinds of other stuff that I explained to last time, I never had 2 rings pop up once I did all this and I started to put it all back together, I had 2 rings pop up. Now these rings are heavy. They're completely filled with Gans water. All of them. Everything that you see in there is all filled. The bottom rings are filled. This one's nano-coated with sugar. This one's filled with salt, non-nano-coated. This one's nano-coated with sugar. This one's non-nano-coated with salt. Boom, 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 boom. So then I have rings, like I told you the other day, of configurations. Here, get this over here. I know exactly which rings are inside the balls because I filled each one's accordingly the way I wanted them. Tower 1, Tower 2, non-nano. These are all nano-coated. These are non-nano-coated. One's non-nano-coated, two's nano-coated. And then I crossed. There's one nano coat here, one nano coat here, one nano coat here. So that I mixed up, there's some nano coat and non-nano coat in each ball so that they would talk to one another because they want to come together. They should want to come together because they're all part of the family. I did this the first time and everything just sank to the bottom. It didn't work. It was like, wow, bummer. So this time when I filled it together, the water that's inside here is from my other experiment, which is 3 types of GANs here, 3 types of GANs here, all combining of the 4. The rings have 1, 2, 3, and we can go to that at another time. But the most significant point today, and I'm so excited, since you've watched, or since this has been on, this guy here, right here, I don't know if you can see it or not, has moved, this position has moved from here to over to here. It's a slow moving ship on a beautiful sea, and it takes about 45 minutes to get around the complete cycle. Would somebody please tell me why this is? This one over here doesn't move in the whole cycle. It just smallly spins itself because I'm watching it because I have arrows on it, and the fill point used to be way over here, and now it's over here again. So if you're here, you could see, but I can only tell you, and you can only believe what I tell you. And now that I'm looking at the 2 that are floating are the 2 from in Tower 2 is 2.5, which is CO2. CO2 is the first to float here. Here in this one, Tower 1 is CuO is the first to have a reaction. Nano-coated, non-nano-coated, not of the same family, but of the same ring size. Hello.
We're here listening. This is pretty interesting.
So I don't know what else to report. I don't know what else to say. I have no motors, but I have a few things moving, and I'm very happy. I don't feel, like some people say, oh, the fields are over exuberant. I had these ideas 6 or 8 months ago, and I threw everything away because it scared the heck out of me. I restarted everything. Everything you see right now, everything behind me, I had 6 months ago, and I was so scared because I thought I was doing the wrong thing. I trashed everything. This time, I'm not trashing everything, and I understand a little bit more, and I had to really do a little bit of soul searching, but this doesn't scare me now. I'm really happy that I'm actually getting a reaction without anything. I didn't buy a motor. I had intentions for that. I had an idea, and this idea is actually moving now. This is an actual movement. See, now if we looked again at this, at the camera position, I haven't moved anything. My hands haven't moved. I haven't touched anything. And ring number, this one over here now, is now almost to it's going in a counterclockwise position. So we can keep on talking for a little bit longer. and it'll end up over here. Well, probably another 10 minutes over here. Without me touching it, I'm not kicking it, I'm not jiggling it. You don't see any water waves going through it. This poor chap over here, the fill point is now way over there. So if we wait another 10 minutes, I think the fill point will be this way because it's moving this way. This is moving this way. And after a while, I'm sure the fields will build up to the point where my next hope or intention or want is the second ring to pop up. Let's get two of them going. Let's get two to the surface because they're not even at the both these rings are below the surface. I thought they'd come up and above the surface, but they're below. Each one are below, and I can take the camera below each pod, and you can see they're barely touching the top of the surface. So there's got to be some kind of field working. Can we get some kind of idea on that, John? Hi, John.
Now you're saying, what are the things that are floating exactly? They're your GAN's balls or the rings?
No, they're not GAN. I couldn't afford to buy balls or ping pong balls. I just had these vinyl rings and
okay,
I bought,
got it.
They're 1/4-inch vinyl rings. Some are, I put caustic solution in the ones that have the black connections in them. These all have black connections. Some have black. There's a couple of black ones in there, but this is the majority of black. This is the first nano-coated ones that are really, this guy popped up fast. As soon as I poured the water in, boom, he was there. Let's move. And he's the fastest moving one.
And they're free to rotate. They're not wired in, or are they wired in? Is the wire rotating too?
They're free to do whatever they feel like doing.
Right. Okay, cool. You know what you should do is maybe a time-lapse photography would be great, because then we could see the movement over several hours or something, and you could play it back over a minute or two and see the actual movement that way.
How would I do that?
Well, do you have an iPhone or?
I do.
Well, the iPhone, you can either get an app or you can actually use the camera app. I see now they have a new option for it, a new upgrade or whatever. You just go to it briefly. When you go to, you can select pano or square or photo or video. Now there's a slow-mo beside video, and beside slow-mo is time-lapse. So what time-lapse will do is just take a picture every so many seconds or wherever it's set up, and it'll give you a movie at the end of it that'll play back like over a couple of minutes, but it'll be hours of time.
If I just turned it on for 12 hours and just left it, I get 5 minutes worth of motion.
Well, let me see here how that works.
Maybe.
Yeah, assume about 30 frames a second. So, for every 30 photographs, you'd have a second of video. You can set your video down to like as slow as 15 frames a second, and it'll still look relatively smooth. But depending upon how it stitches the photographs together, your final output, the time could vary considerably. But if you set so it takes a picture every, say, 30 seconds or 45 seconds, maybe a minute, that should be enough to be able to see the motion really well.
Yeah, I'm not sure if it's how settable it is in the app. I haven't used this yet, so I'm just trying to find out how to set.
What app would it be? What app do I have to would it be like Facebook Messenger or?
No, you've got right in the iPhone. There's a time lapse part. Like I was mentioning with this, it's got slow-mo, video, photo.
I'm sorry, I got a Android.
Android. I can't help you there then. But I'm sure there's applications for that. By applications,
I'll look for it. Because they might have an application for a desktop for slow motion. I want to see slow motion time lapse.
No,
Right?
not slow motion. Slow motion is where you take something that's happening really fast
Oh, that's right.
and you
Okay.
slow
Okay.
it
All right.
down so
Time
you can expand it out. It's the opposite, which is the time lapse. Yep.
lapse. Okay. Okay. Well, I'll look for that, because I got a thing for that, the app store. And if you just put in there time lapse photography, I'm sure they'll come up with some kind of
Yep. Yep. Do
okay.
a little research
All
on
right.
it there. And
Yep.
that
So
There's a
that's
number.
how I have the report. I'm
well,
sure I'll look
that
for
would be
that stuff.
really big if you could do that and it showed some good rotation and so on. That would be pretty exciting stuff. Although with the idea of putting a coil in and basically you have sort of electricity or some sort of fields going through these coils, so it's more or less expected that there would be some sort of rotation. But this would be a great example if you could come up with that, because we haven't had a good demonstration of that yet that I've seen. So think about time lapse if you can.
Don't worry, I'll figure that. That's the easy part. This was the hard part.
Yeah, no kidding.
Okay,
You make it look
that's all I
you
got.
make it look easy and it looks simple, but it requires several months of speculating and thinking and knowing and finding out more and so on to get to the point where you got to. All right, thanks a lot. Perfect.
Anytime, Rick. I'm be more than glad to share whatever I can do. I'm trying as hard as I can. I'm not that smart, but I use my free time as well as I can, and this is what I've come up with. And the next step is the next step. I don't
That's
expect
right.
anything, but
Well, a lot of this work, you don't have to be that smart. You just have to do it. And that's the difference between the doers and the thinkers. You can think your way forever, but if you don't actually try it and do it, then you don't get to actually experience it. And it's the experience of trying, the experience of doing and observing and interacting with our machinery, like feeling it and tinkering with it and just adjusting and changing little subtle things and so on and seeing what differences it makes. It's all part of what this experimentation seems to be about. All right, thanks, Mark. I think I'd like to move to Peter here. He just asked how to do the screen share. Okay, well, screen share is you go to the bottom of your Zoom window. It should say share screen. Oh, you have your video on there now, so we can show that if you want. You've got something you want to show in the video. Is that it?
How's that? Can you guys hear me?
Yeah, we can hear you now, Peter. Let me get you set up on the video.
Okay, I'm just giving you a second here. I'm holding it with my hand so you guys can even see. Now, for that reactor, this would be the solution to getting rid of the compressors completely, and it's a very high efficient solution. What you'd be using is two contactor switches, or just two contactors with the coils. So here's your main. Right here's your main contactor. I got the arrow signs to show flow. Here's your AC in, which would be coming from your exciter. Yeah, I know. Just give me a second here. First time doing it for a while.
Maybe if you hold the paper the other way, 90 degrees to that, because then it'd be lengthwise on your screen. We should be able to see it better.
Okay.
Yeah, that's better.
That's better?
Yeah,
we can see the whole thing?
Yeah, pretty much there. Yep.
Okay. Oh, Dee, I almost need you to hold this.
It'd be a lot more clear if you had a tripod or something to hold it, or if you had a digital file.
You hold it for me.
You can also do screen sharing if you had a digital file. This is a drawing, right, or is it a digital?
Yeah, this is just a quick drawing of what I did with the NREM tech, with a tiny modification to it for you guys for your heartbeat, because NREM tech doesn't need the heartbeat. But what it is here's your starting contactor right here. So here's your positive, negative. Here's your in, out. Here's your coils for your contactors. So what you do is you do the AC in, then you go to your coil, positive to positive, minus to minus. But then you take the other connector to the coil and you go follow the circle to the positive coil on the secondary contactor. And then you take that, follow your flow, put it into the positive in, do the same thing with the other one right here. Just go to your negative to negative, then, or the positive right here, and then go to your negative on your coil, and then do your coil back into the secondary contactor. Now, for the out, you got the two positive, negative going out to your load, stack, whatever. But for the continual infinity loop heartbeat, then you take the positive out and feed it back into the negative in on the first contactor. Do the same with this for the negative, feed it back into the starting positive on the starting contactor, and then it'll just keep looping and doing your infinity loop, doing a figure eight. But you don't have to use the out on the first contactor. It's irrelevant. You don't need to use it unless you want to start stacking loops. But this does, because these are multiple connection contactors, you can do up to 5 connections on each pole other than the coils. Those are just 2. You can get 2 to 4 on each coil. So you could actually stack infinity loops if you really wanted to. But I don't know if that's going to propose extra phase variance or anything like that, depending on your insulation and things like that. But that'd be the best way to get rid of the compressors, because that's pretty well all they're doing. But compressors are very inefficient. You get 32 to 62% loss when you run it through a compressor. They're built to move freon and not to maintain electricity current and the plasmatic state when it's in the state of this. Because NREM tech is the plasmatic state of electricity using a power transference through a phase ripple, and the phase ripple is the plasmatic state. So, and that's what this is doing when it goes through the dual coils, is it turns it into the plasmatic state from standard 120. The ones I use for NREM tech are 240 contactors, of course, but you can easily get the 120s, and they're only $20 a piece, and you can easily wire it up. Some wires, some clips, easy done. And that'd easily get rid of your contact or your compressors, and then it would improve the efficiency by at least 60 to 80%.
When you're dealing with a COP of like 2,000 or 3,000, 20 or 30% doesn't really make much difference.
Well, it's a funny thing with that, because phase variance, when you're doing the plasmatic state of AC energy, a few megahertz can make the difference in a smooth flow or staticky feed, which can really destroy your equipment.
Yeah, Douglas wasn't having any trouble with his equipment at all. What happened during the presentation was he forgot his starter circuit, and when he went to try to build a new one, it wasn't stable enough, and it just ate itself. So he wasn't able to actually start his system. But once his system is started and up and running, he's got a COP of several thousand. Yeah, and for the starter circuit is easy. You don't really even need, well, you can use a direct current permanent magnet motor would be the easiest way to do it. That's what's in all the pumps and everything like that, is just a small one, a very small one. So, it's easy to modify the parts and everything for that. Pumps are okay, but it'd be easier just to actually do a standard direct current permanent magnet motor instead of dealing with the pumps, because then you don't have nothing to take apart or anything. And there is slight variances in that as well for frequency and everything like that, power output, but that's just standard. But this would easily get rid of both compressors, and you'd have as much COP as what the device could produce. Yeah, it's an interesting idea.
Yeah, someone would have to build it and try it and see if we get some sort of resonance with it, or what's going to happen. Like. So I don't know if we could get it a digital off of that screen share, or some. I guess people can use the video and look back on it and get pretty much the gist of where the wires go on those contactors and so on. Would be interesting
Could we
to try.
get you to come on to the Facebook page, The Golden Age of GANs, and put a picture and a write-up in there?
Yeah, I could, and I do have the materials here to do the loop here by just a modification of my independent device here of NREM tech. Just as much, because NREM tech can keep up the plasma until you start getting into like 1,000 terawatts and stuff like that. So, because it uses plasmatic state of electricity. So this is a little tip for you guys to do it. But I do have the stuff here to actually do a demonstration once we finish up with the reactor here.
Awesome. Thank you.
No problem. Thank you.
Yeah, we hope to get periodic updates from Peter, and he's working, or Guy is working with Peter and is doing sort of workshop things, and they're working with each other, and I think that'll be some interesting things that could come out of that that technology that Peter's working with, and perhaps the Keshe technology might be a way that it can mate or work with each other.
There's a lot of compatibility with NREM tech and plasma, but as it is that with plasma, because there's so many people working on it, and I'm one of the only few doing NREM tech, well, actually doing it properly and having actually working systems, then with the proper development and the application of nanotech materials and magnetic bearings and things like that to improve efficiencies, reduce variance, then they can actually blend quite well with each other. So we could actually use a bit of NREM tech in the reactors, and it might help with the phase variance or producing a higher density field and things like that. So there's really a lot of room for investigation into the duality of those two.
Yeah. Good point. Okay, well, build it and we will come look at it. That's our motto here, in a way. But yeah, the parts are all coming together for something to come out of that. Okay, anything else there, Peter? Shall we move on?
That's pretty much it for me. I'll check out the Facebook page there and maybe post a picture of it so you guys can tinker with it. But the cool thing about this is that what if you did multiple heartbeats? What if you stacked infinity loops? Would it increase your power output? Would it increase field density or multiple field? It's pretty interesting stuff. You got enough room after you do the initial infinity loop for another 2.
Maybe it takes 2 to tango.
Possibly, but this would definitely easily get rid of those compressors because they're built to move freon and they're not built to maintain plasmatic state of electricity.
Maybe we need a male infinity loop and a female infinity loop. Let them do their thing.
Oh, they'd always be
good.
Okay, let's not go there. I see there's a question here or comment about from Umar about what about using Ed Leeds-Gallman's perpetual motion holder to hold the necessary initial heartbeat. It gives some sort of picture length there, but I don't want to use that because it's probably a copyrighted picture or whatever. But
have you looked at those, Rick? Those are really cool.
okay, it's like a horseshoe magnet.
Yeah, it's an iron horseshoe with opposite wound coils on each leg. And you take another piece of iron, you short out so you make a complete circuit of the iron, and then you just put a very slight DC pulse into those coils, and that will stay magnetized forever until you pull that shorting bar off.
Right, yeah, I've heard about that actually. It's almost like a superconducting state or something, but it's a magnetic circuit essentially.
Yeah, it's a rebounding B field, if I remember the explanation correctly. The A field starts the system, but the B field just never dissipates. Keeps bouncing back and forth between those two coils and just stays there.
It pretty much keeps it in stasis.
Yeah,
pretty much. Yeah.
I wish I could show that to the. I don't want to show it though. It's probably a some sort of copyright or whatever. It's their personal GIF thing. But anyway,
there's a number of YouTube videos. There's one fella that charged one up and hung it on his shelf for 2 years, and it still had the same amount of holding power as it did when he first started it.
Yeah. So essentially, it's an electromagnet that stays magnetized when normally, when you withdraw the power, it should drop its magnetism.
Yep. And they're super easy to make. You just need a lot of wire.
Yeah, right. It's hard to wind the wire around the poles like that. But I'm wondering, so would a device like that possibly work as an infinity loop? Is that what you're saying? As something like this? Or is this the same principle is what we're looking at?
I don't know if it's the same principle. I think well, I can't really say that. There might be some parallels in there. But no, it's just a little bit of weirdness with the physics that tell us that we don't know everything yet.
That's about it.
Well, the funny thing I find about that, with it being pretty much kept in stasis till the bar's pulled away, it could possibly be, with the density of the coils, it could actually be exciting the etheric energy field / 0 point and using that to help maintain that kind of stasis.
Yeah, I think Bearden kind of touched on that. His math is way over my head, but I understood some of it. And it sounded like he was touching on a little bit of that magnetic B field with his, what was it, the MEG, the motionless electromagnetic generator?
I'm just going to put the link to that GIF so people can at least get the link on our video here. Let me just get that straightened out. There we go. Stick it in there and do a little screen share. Okay, there's the link, and people can check out the little rotating horseshoe magnet with 2 coils, a red and blue coil on it, that are connected and sparked to start with, basically. Not sparked, but what would you say, jump started with a bit of electricity, and then basically they hold their energy for up to years, apparently. It's quite an interesting concept. What if you could get it to have a similar system, but instead of holding the magnetic power steady, it was able to oscillate it, cause an oscillating magnetic pulse.
And if you could draw into that oscillation without creating back EMF, you may be able to use it forever.
Right. That would be cool.
Well, there is. I was doing a lot of research on this years and years ago, and there is a transformer design that basically eliminates the back EMF, which destroys your magnetic fields, and it uses an extra pathway within the plates of the transformer to give a place for that back EMF to go, so it doesn't go back into the electromagnet itself.
Mm-hmm.
Very interesting concept.
Okay, just looking at some. Okay, well that's about it on that. Sort of a bit of a side thing there on Leeds Gallon. Many interesting things that he has to offer. Okay, what else do we have to show and tell here? Where's the self-standing generator that somebody should have built by now? No? Come on, don't be shy. Show the world, please. I only hear sounds of silence.
I haven't got mine built yet. I'm working on the other one right now.
Yeah, well, we've got Guy. He's got many of the parts, but he's had to move recently, so his life's getting a little scattered with his parts, but he's also perhaps able to leapfrog into a better situation to be able to do some experiments and so on. And he's got a couple of refrigerators and pumps and stuff like this, mostly already in existing things that are working, but that hasn't phased us before, so probably won't again. Time to take things apart, try to create a working mag-rev generator. Okay, does anybody else have anything for show and tell here, or any other comments? Or should we call it quits for today? Or was it Don Graham? Did you have something you wanted to show? I think I saw a comment there. You want something to show.
Did you get his system fixed yet?
Going back to see. I thought I read that somewhere. It was a lot of comments. He says, I've changed my headset. Let's try again later. Let's see if there's any other comments after that.
Oh, he says his mic isn't
not
working.
Oh, okay. Maybe next time around then. Anybody else with any questions or comments or other topics you want to bring up?
Yeah, I have something here I'd like to show you for a minute if I
Sure.
can put my video on.
Okay, let me give you, you should be able to, I think. Let me stop the screen share. Okay, just a sec, let me pin it. There we go.
I had ordered some 99.8% pure iodine.
99.8% pure iodine.
Something like that, yeah, or 98.9%, something like that,
Wow.
right? Pretty much pure iodine, little pellets.
Yeah.
I put some in a container, put some caustic in there, put some boiling water on there, and it's separated. And I got about this much GANS on the bottom of the container. So I washed it with distilled water, and it's separated and it dropped down to there. I washed that a number of times and couldn't smell anything, and the water looked very pure. And I poured off some of the water of the GANS to use, and then I filled it back up with distilled water, and it didn't separate. I thought that's impossible. Iodine can only mix with ethanol or alcohol. Yet it's completely mixed and will not settle. And
this was on the fourth time or something, you mean? The third or fourth wash?
Yeah, about after the third or fourth wash, I've got a bottle over there, pure water. Let me get it and see what it smells like.
Does Mario know what the pH level is?
No, I cannot find a pH tester. I need it really badly too. I think I screwed up on some experiment. I've got my pyramid reactor spinning here over a bucket with 3 balls inside the balls and stuff, but trying to get motion, same as you, Mark. But this is the water I poured off it to keep pure, looks pure, no smell. But this now smells sort of like iodine again, but that's shouldn't be mixed. And it's got like an alcohol smell. So it seems to have, I don't know, turned the water to wine or something. I'm not really sure.
It was water and not vodka?
Yeah, mix my beer in there or something, I'm not sure.
Well, this is kind of odd. Mm-hmm.
Yeah, something.
Mario, did you taste it?
Yeah.
No.
Probably not.
No. But yeah, that's supposed to be impossible, isn't it?
It doesn't even look dilute. It looks like it's mixed. It's quite dark.
Yeah, and it was only this much, about a third of it.
Did you shake it? Did you shake it extra more? Or is there anything that was different this time?
I'm not even sure I shook it. I think I just poured the water in there and it got mixed. I might have shaken it a little bit like that.
Is iodine poisoning? Is the iodine poison?
You wouldn't want to eat it or drink it, no.
No, you wouldn't want to drink it, but if you just touched it on your tongue, would it be critical, or would it hurt, or would it be
I think
acidic,
I
or-
was reading up about iodine.
I
don't
mean,
know.
we know enough about iodine. If we put it in your cut, when we cut ourselves and we put it on the cut, you know, that red stuff, mercurochrome has iodine in it, it burns.
Yeah, but you don't want to be putting iodine GANs or any kind of GANs on your tongue if you don't know what you're doing. It's not worth trying. What if it's 1,000 times stronger than normal iodine because it's in the GAN state, for example?
That's what I'm asking you. Is iodine poison?
Well, it's let's look it up on our friend Wikipedia and see.
Yeah, and there's a danger sign on the container.
Well, of course, but you're in a GANS in a liquid state.
Oh yeah.
Oops, somebody's.
No, I mean on the container. I mean on the container that I bought it in. There's a warning there, danger.
Of course, because they put all kinds of poison in.
No, that was the pure iodine, 99%. Let me see here.
You can get iodine poisoning by touching raw iodine. Where the way it absorbs into your skin, you can get iodine poisoning, but because it super saturates your thyroid and stuff like that, so it can't actually regulate it. It just goes.
If you touch your finger on pure iodine,
you got to be careful with it.
Directly to your thyroid.
But nascent.
Right? That's what we're asking. The question is, if Mario touched that with his finger, it would go directly to his thyroid.
The thyroid pretty much regulates all the iodine in our body, just like the pineal gland.
Just like brown seaweed does. So if we took in brown seaweed, which is the highest concentrate of iodine known, brown seaweed is very high concentrate of iodine, and if you took that in, which I do, you could buy it at a health food store. Brown seaweed is everywhere, and it's at a very high level, and you can take it. They tell you. I mean, the Chinese take it all the time. So
yeah, that's right. The Japanese too, and says the dosage is no more than 3,000 micrograms per day.
Per day, yes.
That's the tolerable upper intake limit. And Japan's consumption is close to 1,000 to 3,000 micrograms a day, so it's in the upper limit, basically, of.
Exactly. So these people have been taking it for a while, and they haven't been poisoned by it.
Yeah, but that's not straight iodine as well. That's
okay. I know.
Probably
I know.
potassium iodide or something like that.
We're not asking anybody.
Here's the toxicity. Here's the toxicity thing. The lethal dose for an adult human is 30.
Can you share screen
Sure.
with Wikipedia?
Sure, good idea. Let's do that. Okay, so just to look at so we see this is the Wikipedia for iodine and gets into all of its specifications, but let's look down at there's a dietary intake where we just mentioned there's toxicity. The lethal dose for an adult human is 30 milligrams per kilogram, which is about 2.1 to 2.4 grams for a human weighing 70 to 80 kilograms. The toxicity derives from its oxidizing properties, through which it denaturates proteins, including enzymes. It's also a skin irritant, and direct contact with skin can cause damage, and solid iodine crystals should be handled with care. Solutions with high elemental iodine concentration, see that's the elemental iodine, such as tincture of iodine, which you're familiar with, and Luigio's solution, are capable of causing tissue damage if used in prolonged cleaning or antisepsis. Similarly, liquid providone iodine, betadine, trapped against the skin resulted in chemical burns in some reported cases. So, I mean, it's toxic, but you'd have to do more than just touch it to your tongue to kill you or anything. But still, that's the elemental iodine. We don't know what the GAN's properties are, and like I say, they could be thousands of times.
Mario washed that with CO2, which we know is a cleaning element of our process. We know that CO2 is a curing process. And if he was really worried, you could put a little CuO in it, which is a healing process, which is copper. So therefore, the two elements there would cancel out anything that the iodine would do. Plus, there's iodine. If we make anything with the Himalayan sea salt, you have iodine in the product already.
That's right. It's like up to 5% iodine in sea salt. That mentions.
So you know what? I made all my salt solutions, and I have a thing. My very first 5-gallon. I have fat. Because I used Himalayan sea salt. I put my feet in it, like Caroline told us to in the very beginning. If you want to connect yourself with any of this, your humanality has to drain off in it. And if you took hot water and put your feet in the hot water and put the Himalayan salt, the salt will draw your amino acids out of your feet into the salt, and now you work with that water. That is your basis for everything that connects us with this system. You have everything. You, yourself, and I, with the iodine, the calcium, and everything else that goes along with all the things that go along with it.
The thing that's interesting about this turning it into a GANS is, according to this, if you scroll up the page, you see the bonding. My understanding was iodine can only mix with alcohol. So how did it mix with water?
Well, didn't you put CO2 in it?
No, I used distilled water.
Just iodine and distilled water?
It's iodine and distilled water that's completely mixed.
Do you have a reactor already working in your house?
Well, I do now, but I didn't then. I think I have the GANS of soul.
Well, Mario, you deep with that, you know that, so you could have probably changed the property anyway, but.
No, I mean, in another GANS, something happened that's kind of really too bizarre. But the iodine is not the field strength of the human soul, but I'm thinking that it's probably the field strength of the soul of other creatures on the planet. So I actually put a drop of it into the reactor that I have now and into the balls, and see what happens. But the human soul, I'm wondering. Well, anyway, but why would the water mix with the iodine?
Well, here's an answer. Perhaps it says here under the disinfectants section that there's tincture of iodine, which is iodine and ethanol, or iodine and sodium iodide in a mixture of ethanol and water. But then there's Lugol's iodine, which is iodine and iodide in water alone, forming mostly triiodide. Unlike tincture of iodine, Lugol's has a minimized amount of the free iodine, I2 component. So let's look that up and see what this guy's iodine's all about. Lugo's solution, first made in 1829. It's a solution of elemental iodine and potassium iodine in water. And you see it's antiseptic, disinfectant. Mentions this triiodide. Maybe it's triiodide is what you ended up making there. Let's see what that is.
That caustic soda.
Whoa, look at that, eh? Triiodide is like 3 in a row. 3 atoms in a row. Very strange.
And does it bond with water, though?
Well, it was made with
It
water.
says
so water
it's
separated the 3, didn't it?
No, it was separate at first. It always sank right down to the bottom. It took, a minute for it to separate. And then all of a sudden it didn't separate after the 3rd or 4th time.
Because it probably accumulated more water than what you first started with, right? Because if it was made with water and you keep on adding more water, if it was a water-based solution, you would keep on adding more volume of the color into the water solution. Does that make sense? As he washed it more, if it was this type of iodine, it would spread itself out accordingly to the water that it didn't give it.
But it didn't. The first,
what would happen if you put CO2 in it?
Well, I don't know. I'll try that.
Yeah.
I'll try that with some of it.
Well,
but the water separated first 3 or 4 times. And then when I was pretty sure I had it washed, I poured out some of the water of the GANS. I was going to use the water of the iodine GANS. And I had that, and it's perfectly clear. So it was separating back down the same amount I started with. I washed it. I, drained out the water. I ended up with about the same amount again. And and then like the 4th or 5th time I poured the water in, it mixed up, but it didn't separate.
Are those plastic bottles you're using, are they biodegradable?
Who knows?
Yeah, there might be some interaction there, yes.
If they're a biodegradable bottle, there's probably a starch component there, which is going to create iodide, which will bond with your iodine and create triiodide.
Yeah, it says here, the triiodide ion is responsible for the well-known blue-black color, which arises when iodine solutions interact with starch.
Yeah, but that's not blue-black, it's red.
I just got an idea there. The blue-black, because I made my stuff in plastic, like the gold and the zinc, and the little pile of blue-black that's on the bottom is the contaminant of the CH plastic container.
Yeah, it's possible that the plastic has biodegraded and turned into alcohol.
Wow, very smart. Woo!
Because it smells like alcohol-ish now. So I'm thinking that it actually turned the water into alcohol, probably from the bottle. I don't know.
Interesting.
I mean,
Rick, could you just repeat that for me one more time, the blue-black thing that you just read?
Well, it says that, I'll give you the full paragraph. Let me see if I can blow it up a bit here.
You can get iodine from sea kelp. That's one source.
Yeah, brown sea kelp.
Yeah, it mentions that. So the triiodide ion is the simplest polyiodide. Several higher polyiodides exist. In solution, it appears yellow in low concentration and brown in higher concentration. The triiodide ion is responsible for the well-known blue-black color which arises when iodine solutions interact with starch.
Oh, okay. Where would the starch come from?
Well, that's what we were talking about, maybe the CH3 from the walls of the reactor, the plastic.
Yeah, but when I make my GANs, like I said, that there's a little blue-black pile that comes in. It's only plastic and the two metals. So that would have to mean that that blue-black would come from, it has to come from the plastic, which is contaminant, right? Is that the starch? Do they make that, you know, like I buy these little round containers. Is there starch in any of these? Would they make these plastic would there be starch in these containers?
In some of the biodegradable containers, there would be a component of starch. The chemical formula for the starch molecule is C6H10O5. So there is the possibility that just the degradation of the plastic and having that oxidize could create a starch component.
So we have to find out if, you know, Ziploc or Zip, I'm sorry to talk about manufacturing, but do they put that component in there?
In high density polyethylene, probably not, but in a biodegradable plastic, they would, yes.
In these containers that are we making these things in, all plastic?
Well, the Mario didn't make it in a Ziploc container. He made it his in a reusable plastic.
What I'm saying in mine.
Yeah, it's possible that iodine might react with plastic. Something comes to mind that iodine should be in a glass container. Is that true? Did it come? Is that true that iodine usually comes in a glass container and not plastic? I'm wondering about that.
Doesn't the iodine come from the Himalayan salt that we work with? So I put it in the plastic. So now in the Himalayan salt that I make everything in, blue black goes to this.
Probably that's probably where you're getting the color from, because not everyone gets that, and because not everyone uses the Himalayan salt, which is the highest in iodine of all the salts.
Right.
Yeah, we know you've got with your plastic, you've got a CH bond coming off of that plastic, and there is oxygen involved. So some of that CH bond is going to link up and create a simple starch.
Yeah, so there is starch. So I have starch in every single thing that I've done.
Well, it may not be starch as, you know, the object that we're used to calling starch, but it might be some other CH combination, because carbon, hydrogen, oxygen are common to many compounds. You get rid of the oxygen, you got CH, and you got a bunch of C's running around and H's running around, and usually in an ionic form. So they're sort of dissolved already in the.
So these polycarbons that they're making nowadays in these containers, there's these people that are in these facilities are saying, we got to make them biodegradable. So we're putting a little starch, whatever chemical form there is, in the cap, in the whole container of the mixture. Somebody's saying, put a little starch in there.
Well, essentially it's a starch. They use an alcohol-based plastic usually for biodegradable, and it's kind of special. They can make a bag that when you put water in it, it dissolves within a few minutes or hours, depending on how they have it set up, as opposed to a regular baggie. It'll hold water for years and won't break down, and that's one of the big problems in landfills and so on, of course. So yeah, they've had
starch we use. Let me just ask, what is starch used for?
Oh, it has all kinds of uses.
It's sticky, binding, gooey stuff. Generally, like think of dough in bread.
Away?
Pardon me.
So, is it a feeding? Is it something to feed us? You know, like
think like of bread starch, cornstarch, wheat starch.
So that's the protein that starts the life, right?
Rice starch too.
Well, starch doesn't really support life. When it mixes with the enzymes in your mouth, it turns into a sugar. It's basically a natural polymer, and when we break it down, then we can utilize some of the components of it. But when we break it down in our mouth, when we eat it, it just turns into a sugar.
It's not the same as protein, right, John? Protein is a different component of the grain.
Yeah.
Well, that would explain what's happening with mine. It's turning the plastic. The iodine probably turned the plastic into the sugar. The sugar has fermented into alcohol, and I'm mixing it with alcohol now. Because this is not a triodide. What I have, it's not blue black. It's the same color it was. It's just that it's completely soluble. It's dissolved into water, which it's not supposed to be able to do.
Okay, Mary, you can test this really, really easy. Just do another one exactly the same way, but do it in glass.
Oh, yeah, okay.
That's a good test.
Yeah. Okay, let's know. Thanks, guys.
Hey,
Thank you.
thanks, Mario.
All right, what else have we got for show and tell night here? Oh, what was that?
That was Peter.
It
Had the speakers up too loud.
sounded like an alien spaceship coming in from here.
Hey, Rick, just one more thing about that design for Manicam here.
Okay.
The best way to do it is what I found with all the different testings of the wires and everything like that, all the way from 14 gauge to 6 gauge and everything like that, from stranded to non-stranded, is the 10 gauge stranded works the best. It has the best variance control for the frequency in the near plasmatic state. With the stranded, when you don't use the stranded wire, then it's really like brunt force. There's not much room for any type of frequency exchange or anything like that. So the 10 gauge stranded with just the quick little female clip is the easiest and best way to go about it.
Okay, thank you. And I think it's interesting that I believe it was it 10 gauge stranded that's in the latest capacitors. I'm just bringing it up here.
Yep.
14.
Yeah, the center core.
14. No, it's 14. No, 8 gauge stranded copper is for the core of the plasma capacitor. Looks like. And 14 gauge on the outside, but 8 gauge on the. It's pretty darn close to 10. Next size smaller or bigger rather. Interesting. I wonder why they went with stranded for that core, although I've been thinking of the same thing myself and looking at this nice 10 gauge stranded that I have that's from a what do you call it, a stereo system. These real skookum stereo systems now, they use very nice copper stranded wire, many strands. I'm thinking if that was nano-coated, it would be, you'd have so many multiplicities of layers involved and different, well, basically like Peter was saying, different frequencies, different channels, you might say, of ways the plasma can flow. So maybe that's our hot new secret, is to maybe we should be winding coils with stranded wire even.
I do find it does actually help quite a bit, because I've tried it with the 8 gauge regular, and I've tried it with non-stranded, and it does, when the electricity flows in its plasmatic state, there's not much room for any variance, so it's really brittle. But I find with the 10 gauge stranded is that you've got a lot more wiggle room if there's different frequency variances in the different power sources. So when you loop the contactors, there'll be the slight, plus minus 5 hertz frequency variance as with all electricity. But when you do that, the stranded helps compensate for that rather than the non-stranded when it doesn't have that wide variance angle.
Mm-hmm. Well, that's true in even like antennas for crystal radios and that sort of thing. They use what's called Litz wire, which is a specially wound wire to maintain the fields without disrupting, self-canceling from the induction of the wire and so on.
Yeah, I've built antenna systems, wire antennas out of stranded wire for 11 meters, and they were ridiculously easy to tune. So there's definitely something there. I'm wondering if like the audio type cable with the very, very fine wire in the stranded would increase that effect somewhat. Because a typical 8-gauge stranded wire, what would be the wire diameter? 22 gauge, and there'd be probably 30 of them in there.
Probably
But if you
something
went
like that.
like a gauge with, say, 100 strands.
Mm-hmm. And you think about each strand is so tiny, and maybe if you were to nanocoat it, then maybe the nanocoating would actually etch into the wire enough that there'd be barely any physicality copper left, which is actually the best the best position to be in, but to try to have as much of things in the plasmatic state and get rid of the physicality if possible. Mr. Keshe talked about taking a copper wire, say a 14 or 10 gauge or whatever, solid, and doing a nano coating on it, and then melting out the interior of the wire, get rid of all the copper so there's only nano coating left, and using that for transmitting power. And that,
Well, if we could find wire that was 60,000 to 100,000 atoms thick, then yeah, we could do that. It would be 100% nano-coated.
right.
The 8-gauge stranded is a 7-strand 16-gauge wire.
Oh,
and,
okay.
And a 10-gauge wire is 7-strand 18-gauge wire.
That's in household use, but if you go to a stereo supply, like especially for automotive stereo, where you have to use really thick cables because of the 12-volt connections, they use a very fine stranded. I think I have some here. Let me see if I can find it.
Yeah, you can find the same kind of wire in high-frequency, high-power radio applications too.
I know. I've got some 6-gauge out in the garage. I hadn't thought about using that. That's big enough for jumper cables.
Yeah, welding cable. There's a good example of it. If you look at a high-performance welding cable, it's very, very, very fine wire, and there's a lot of them in there. That's so that it can carry the extra current.
Nano-coat that, and you got a lot of square volume of nano-coating.
Most definitely. But yeah, the audio cable, monster cable. I used to have it in my Honda when I had the car on the road, the big stereo in it. And the cable feeding the speakers was like the size of my little finger, and there was probably 200 strands in it.
I was going to, here we go. Just going to show, it's actually, I exaggerated, it was actually a 12 gauge. I thought it always seemed to be thicker than that to me. Probably because it's doubled up. It's clear. It's not clear enough to see, but maybe I can show it easier here.
That looks like a standard speaker wire.
It is a speaker type wire, but it's just got lots of strands to it. It's particularly fine, lots of fine strands. So the idea is there, I guess the fine strand works better, and it's also tends to flex a lot easier than the larger core wires, which household use you might tend to take a multi-core wire and stick it in a wall, and it generally doesn't move around after that. But these speaker wires might move around, and they make them really heavy duty for automotive use. The coating, the cover is heavier, and the wires themselves have more strands. So interesting. And this stuff nano coats quite well. I've done tests with one end starting to nano coat, and you can walk through the clear cover. You can watch the nano coating go right down the length of the wire. It's amazing.
If you could ever get the insulation off that, maybe that's the way to get megawatt generators or megawatt megravs.
Yes, indeed. Yep.
Yeah, the only thing is, you try to wind it into a coil, it's not going to hold its shape very well.
Yes, well, there's always the problem with the physicality. It just doesn't hold its shape under stress. What do you got there, Mark? You're just holding something so delicately. I'm going to have a look at what you're doing there.
I shook it a little bit.
I thought it was a birthday cake for a minute, but no, it's... You shook it. It was settled out GANs in there. What did you have?
Oh, I got my mic on. I thought I had to sit down and turn it on. But I just want to give a shout out. And I shook it too much. But I just want to show people that they can make this.
And what is it?
Ah, doggone it. Well, maybe you can see it on this side.
Is this gold GANs or something else?
This is actually a shout out to Jackie. I know we've been talking about a whole bunch of stuff, but I wanted to at least show this because this is the Sopal, the fruit from Africa.
Mm-hmm.
Actually,
soursop, I think it's called. Eh?
This is from Paul from Africa,
Mm-hmm.
and then I have in here the shea and cocoa butter,
Mm-hmm.
and the I shook it up too much, but I have it's separated beautifully, and I should have just left it up on a shelf and brought the camera to it, but I have so many experiments, it's not even funny.
Mm-hmm.
But this is a good shout out to these guys because this is going to give us the whole component of everything Mr. Keshe told us about. The Sopal. Am I saying that correctly?
I thought it was soursop or
Soursop.
Soursop, I think.
Yeah, it's a fruit from Africa.
Yep.
I did that with the the HCl, our stomach acid, and some capsules, and the cocoa and shea, and it came. I just want people to know, the pH on this is 2. I can't even believe it. Everything I've done, I've got pHs from 12, 7, 4. This is a beautiful 2. And why do you say that's 2? Because between the bottom and the top, the energy, oh, there it is. Look.
Mm-hmm.
Can you see that?
Yeah, it peaks in the middle, kind of.
It peaks right here.
Mm-hmm.
And Paul told us that this, and Mr. Keshe told us, it's the perfect feeding. We might need this pretty soon, and it's broke down. This all was broke down with this HCl, the hydrochloric HCl. Am I saying that right, Rick?
Yeah, hydrochloric. That's right. Yep. Well, that'll be strong acid, so you'd have to make sure you flush it really well with that, or it'll make your pH quite low.
Well, it is super low right now.
Mm-hmm.
That's what it's been made in. As soon as I flush it, you know what I'm saying? Then it's already separated itself. It's already making in this low atmosphere. The fat is at the top with all the cocoa and shea, and the what's it called?
Soursop.
The fruit soursop is at the bottom.
Mm-hmm.
They won't come together, and it's usually clear in the middle. Like Jackie said, he got 3 different layers:
Mm-hmm.
dark, clear, and fatty.
Mm-hmm. Interesting.
So I just wanted to kind of show everybody that this is a very nice combination. I think we're going to be able to use this in the future here as far as the feeding portion,
Mm-hmm.
because it has everything we need in it.
Mm-hmm.
And I've been putting it on my skin, not this part, but in different applications. The cocoa shea.
Mm-hmm. That should be good for skin, yeah.
Look, Rick, I made this for my friends. My mom's friend with the cocoa shea.
Mm-hmm.
in CO2. And there's just a touch of water in there, and they rub it on their achy parts.
Mm-hmm.
They're going like, oh, I don't even. My mom's 91, and she's ready to go back bowling again.
Yeah, right on. Nice. Good story.
It won't be long before she'll give a testimony here in the reactor.
Yeah, that'd be nice. That'd be excellent. Look forward to it.
3 more weeks.
Right on.
So yes, we're working hard here in Detroit.
Thank you for update from Detroit, Mark. Excellent.
Okay. Sure.
Okay, we got Menachem has something in video that he's showing here, and we got Peter saying something about take a look at my video as well. I'm not sure what's happening there. Let's have a look at this.
What I was showing, what my quick video was showing, was just the contactor that I use for the independent energy device here. It's just a simple 2-pole with the coil contactor. You don't really want any of the overload or the 4-pole. You just stick with the 2, the line and the load, and it makes it really simple, and there's not much for a throw or anything. So it's just 2-pole with the coils, and that's all you need. No overload or anything. It just makes way too much variance when you start doing the plasmatic effect.
Okay, well, we'll keep that in mind for people that wanted to experiment with that. And what are we looking at, Menachem here? What, this...
He's just showing his contactor to me.
Right, I see.
Get an identification on it, and that's a 4-pole with overload.
Right, okay. Good, I understand now. All right. Okay, I think we're going to wind things up here, guys. Going on 3 hours or so here. And that's probably enough, unless there's anything else we want to add at the end here to complete things.
Nothing but thank you, Rick, for another great job that you do for us every Tuesday night. I look forward to it. I'm so happy to see your face one-to-one, and soon enough we'll be together on our RV in space.
RVs in space. That'd be a good video, a good movie.
Just one more thing here. I'll show the drawing I did of the contactor. The camera won't reach the device, so I'll just do a quick little showing of the type of contact we use.
Okay. There it is. Yeah. And the little legs on there are the wires coming out. Is that the idea?
What it is on each pole, you got 4 quick clips, and then you got another, so you can do 5 connections on each pole, because there's the one which is the screw for your direct line, and then you can just use, then there's 4 quick connects.
Mm-hmm.
And then on the coils, there's just 2 quick connects, but you can always put a splitter and get an extra connection or 2.
I see. Right on.
That almost reminds me of an RF antenna relay.
Kind of thing, yeah, it does kind of look like that.
Okay, just pin myself to the second video there. All right, thank you very much. And I think that's it for today. And once again, I thank everybody for coming by. Let me just check the live stream here in case there's something I should be saying. Pontus mentions, hello everybody, to the hybrid starter or heartbeat. In some way, could we use a bucking coil to get the oscillation that's needed? Please look this up. Yes, bucking coil could be a way to go, I think. People can look that up and try experiments with it if they like. Or some kind of pulse circuit is another thing that we could look into for those that are experimenting with this heartbeat, this pulse that we need to initiate our plasmatic circuits.
Hey Rick, what I'll do is next time you're at the office here, I'm going to be bringing up my my direct current permanent magnet motor that does that. You know, because it's been taken off the shelf and purposely hidden. So, you know, you can't find blueprints of it anywhere. And when I contacted Leeson, the manager in Vancouver, he said that it was built for a very special purpose, but that's all he could release. So, but it does have that magnetic pulse in it.
Yeah,
that we
yeah.
could use.
I think that'll be interesting. That'd be definitely something that I'd like to see tried. So bring it on down, and we'll get Guy and me in on it there, and maybe we can
I'll have it here tomorrow.
Figure this situation out. Right on. Okay, thank you, Peter. Thank you for showing your other things as well, and thanks to everybody for showing things today, as usual. And that'll be it for today's Plasma Reactor group. And as usual, it's been fun, and I enjoy all of your company. And stay tuned next week. Maybe we'll actually see a hybrid plasma generator created by one of us here. That would be nice. I'd like to see someone from the Plasma Reactor group actually create a reactor that could generate power and or some other effect. I would go with light, and if it generates lift, that's actually the holy grail, and that would be truly nice. But let's see some sort of effect. We've seen effects where people can feel things and sense things. Well, let's see if we can have some sort of effect that everybody can agree on, that this is a anomalous, something unusual to our modern society or modern culture. Yeah, just free off a grid energy to charge a phone would be grand, says Menachim. Never mind a hairdryer. So yeah, that's true. We have a hard enough time keeping our phones charged.
Do it.
Right on, Mark. That's that Yankee spirit there. Yeah, I went to school not far from Detroit, you know, in Flint for 2 years. General Motors Institute. That's another story. Okay, I'm going to sign off for now, and we'll call it quits. Thank you, everybody. Bye for now. End the live stream.